All right, I'm going to go ahead and start sharing my screen. Let me know if y'all can see this. Cool. All right, so you should have already gotten the link to our code of conduct, but just in case, our normal rule here is just to be good to each other. Treat everyone fairly. This is going to be a pretty diverse group of folks. Some people are going to be sort of new at coding or newish to coding, and other folks probably have a lot more experience and you're just really interested in the details of OpenCV. So hopefully we're going to cover both use cases. It's always a bit of a challenge in coding workshops, but I think we've got it set up so we can. If you are interested in helping out, we really appreciate maybe during the breakout sessions, if you do know a little bit more about Python and you see people are struggling, we appreciate when people can help out, but it's sort of up to you. Improper behavior, abusing our Slack or our Zoom chat or Slack channel, you can notify Leah or I and we'll kick them out. Sorry, this is like the one thing I have to say is we do have a zero tolerance policy. I've never had to use it yet, and I hope I never do, but just want to say it just to make sure. And for whatever reason, if you think Leah or I are causing issues, you can let the other person know. God forbid that happens, but yeah, just to say all that up front, just so we make sure that everyone feels comfortable here. I'm just going to jump into real quick intros between Leah and I in case you don't know who we are. I see there are actually lots of returners from previous classes, as well as some people I know through the internet. We won't have time to do intros amongst all of us, so what I recommend doing is dropping your name, where you live, where you're located, maybe a link or two to either your Instagram or your account in the chat. That way everyone can get to know each other a little bit. We do actually have a Slack channel. It's just an open Slack channel in my Slack called OpenCV Workshop. We'll use the chat mostly for talking right now. But maybe post-class, if you want to follow up with people like, hey, I saw this thing you were making, it was really cool, or any post-class announcements or maybe even questions as you work through this stuff again, we can use that. So you're welcome to join that in there. It's just OpenCV Workshop. Yeah, so go ahead and drop in your name, where you're located, and yeah, link to yourself. So I'm Derek Schultz. I'm a designer and artist. Most of my work these days is in machine learning. This is some of my style transfer work. I've recently been doing a lot more sort of in the video realm. And relevant to this class, I use a lot of OpenCV tools, which are sort of like, so a little bit about what OpenCV is to get started, but lots of sort of proto machine learning tools or pre-ML tools. And this course in particular is based on a library of tools that I manage called Dataset tools, and we'll sort of cover a very small portion of those tools in this course, and hopefully you'll learn a little bit about that and can sort of work from there. And I'll talk a little bit more about Dataset tools when we get into the course more. Leah.
Hey everybody. Yeah, seeing a lot of familiar faces, so that's really cool. Yeah, I'm Leah. Next slide. This is just a little brief history. This is maybe like 2 or 3 years ago. My first foray into machine learning art. Sort of came to it from the technical side, being a machine learning engineer and then a researcher. But now I'm just, experimenting with the cool and creative ways to use machine learning in artwork. Like Derek, I'm also exploring a lot of video. A lot of work that I do right now is like audio reactive machine learning generated animations. And so this was Stalgan network, and then I put it into Touch Designer to make it audio reactive. Oh, shout out to Emily. Emily's also in the audience. Emily Saltz and I and Claire Leibowitz have created this digital zine / guide on if you're making art with, or if you're making art with AI, just things to be cognizant about when it comes to like thinking about your process critically, like who's affected, power dynamics, ownership, all of that good stuff.
Awesome. So yeah, welcome everybody. Glad to see we're getting a bunch of folks in various parts of the world. Really nice to see all of you and hope we can chat more throughout the session. So I've shouted this out a couple times now, but we do have some prerequisites for this class. Probably the more important one for most people to get up and running, well, certainly both these are important, is to have an Anaconda installed, especially if you're on a Mac. If you have another, I know someone said they use virtual environments. If you have other virtual environments, you're more than welcome to use those. I find Anaconda to be fairly simple to use. And I say that fairly as like it can be a bit of a challenge sometimes. But it's definitely important to use that, in part because with Python, there's so many versions of Python, especially pre-installed on Macs, that it can cause a lot of issues if you are trying to run some really basic stuff through Python. There's a bunch of dependency issues. So Anaconda makes it a little bit easier for everyone, so it's helpful to have that set up. And lastly, you do need a code or text editor. I'll personally be using Sublime Text 3, which is just like my code editor of choice. The cool one now is VS Code, but there's a bunch of others out there as well. You're more than welcome to use whatever you want. For this class, I mean, we won't be doing anything super complicated that you require linters or other things like that, but there are good Python linters available for both VS Code and Sublime Text 3. If you don't know what a linter is, don't worry about it. We can deal with that stuff later. It kind of helps you like manage your code and make sure everything's written correctly, but it can also look like a big pain in the ass, so don't worry about that too much just yet. So please make sure you have Anaconda installed. I would say if you do not yet have it installed, we can probably work on it together through one of our first workshop breaks. So with that in mind, a little bit about what we're going to do today. So I've sort of broken this up into 3 different lectures or demos, and then a series of self-exploration time. So we'll do 30 to 45 minutes of lecture, and then we'll have 20 to 30 minutes for people to sort of like play with the code, maybe extend the code a little bit, sort of like learn by typing some stuff out and messing with it. So that small group exploration time will also be if you do have like major issues like you can't get something running. First off, please make a note of that in the chat. Leah might be able to help. So Leah's going to sort of be my chat guru or my chat guide and sort of like, answer questions that come up in the chat and probably stop me if there's anything major that we see happening and I need to go back and cover. But we'll also have the small group time if you do run into issues. Leah and I will sort of be moving around the various breakout rooms to sort of help answer any questions that people have. So it's a good time to sort of get a little bit more one-on-one time with us. And also, like, obviously for a 3.5 hour workshop, no one wants to sit in a chair for that long. So please do feel free to stand up and take breaks during that small group time. So basically, like, every 45 minutes, you should be able to stand up and stretch and walk around for a little bit, get some water, go to the bathroom, that sort of thing. So a couple other notes. As I mentioned, we probably have a pretty diverse group in terms of coding experience here. So for those of you who are serious coders, you might cringe at my code because I will not be doing like the most dry, like we won't be using classes or objects or other things in this course. We'll be just sort of writing out just the basics, and it won't be the driest of things. So obviously, if you are a professional coder, you know your way around, writing better code, please feel free to do that. If you see me doing something egregiously wrong, you're welcome to shout it out. But also, Leah and I are sort of like artist first, coder second. So we won't really be doing the most perfect things. It happens. The hope is that you learn a little bit of just how OpenCV works, maybe how you can think about OpenCV, and then you can design something much nicer that way. And obviously, like in a short 3-hour course, there's a ton of stuff that you can do with OpenCV that we won't cover. Everything that I'll be doing is going to focus pretty much exclusively on sort of like managing images and data sets. But there's a lot more you can do with OpenCV. So I definitely encourage everyone check out more opportunities and see what's available to you. Okay, I just said this again, but yeah, so we're going to structure this so that hopefully there are things that like people who are really good at coding can jump in on, and then for other things, people who are new, like you can just sort of get your feet wet and feel comfortable with it. So we've sort of structured it so that during the breaks, we'll also be offering sort of like what I would call challenges, or things that if you have sort of like, you totally understand the material that I already covered and you want to sort of like maybe try some experiments at extending things, I've got some ideas or thoughts and places that you can do, and you can spend that sort of group time to do that work. So hopefully that'll like help out the people who are like really good at coding or like already have a handle on this, and maybe get them to think about how we might even make this stuff cooler. And obviously Leah and I are around to answer questions on that as well. But then if you are new, you can ask us questions about like, why am I getting this error in Python, those sort of things. And lastly, again, if you have experience, like please help each other out if you can. It's not a requirement, no one signed up for this class to be a teacher themselves. But if you are able to help out, it's really appreciated. So objectives for this class are just to learn a little Python. So I know a lot of folks have mentioned that they have JavaScript experience. So I'll briefly touch on the differences between JavaScript and Python. They're actually not as big as I think, or like some of those people make them sound. So we'll cover that. We'll learn some basic OpenCV. So we'll just look at how to do some things you might see in an Intro to OpenCV course. That'll include manipulating images, so doing cropping, padding, looking at some edge detection, and we'll talk a little bit on Numpy. Numpy isn't like the biggest part of this class. Numpy is like sort of a math library that comes with Python or can be added to Python. And it mostly comes up when we look at things like image cropping. We'll look at some NumPy slicing. And we will look at some slightly more complex stuff, so that'll be for the last session of the workshop. We'll look at doing some edge detection and using contouring. So as I mentioned, this is based on a library that I've been building out for the past couple of years. It's called Dataset Tools. The link is here. I will add it to our chat as well. So I would say that after this class, you should be able to sort of like dig around through this repo and maybe understand a lot more that's going on underneath the hood. And my secret hope is that maybe this also means a couple of you can start adding changes or submitting PRs to it. So far, it's been a labor of love that has been mostly just me. But I think there's lots of opportunities to extend it to various use cases. So if you are interested in sort of building that out more, like please feel free to get in touch with me or submit changes and PRs directly through that GitHub. So let's talk a little bit about like why we would do this, like, or what's the whole point, or like the point of view for this. So making image data sets, you really need a massive amount of images, right? So if you're working on something like StyleGAN, you're talking at least 1,000 images plus. Many of you have probably gone through that process with a class with Leah and I, and it's really time consuming to do it by hand. And some people know Photoshop actions, but I've personally found Photoshop actions are kind of brittle and don't really actually allow for like that much intelligence, right? Like you can do some if-else stuff, but it's like pretty hard to do more beyond that. So that's where OpenCV really comes in, and it's a really like important, powerful tool. So OpenCV is a library of computer vision tools. It's existed for a while now. And computer vision and machine learning have like sort of a Venn diagram of overlap. I would say in general, like computer vision isn't as complex, right? It's not really doing deep learning, but there is a lot of opportunities to do stuff you wouldn't want to do with machine learning. It's like too intense for that. Also, what's nice about OpenCV is it runs completely on CPU, so we can run it on our local computers. And it does allow us to do a lot of like interesting and complex image transformations in just a few lines. So it has a lot of like complicated math and other things going on, like signal processing behind the scenes that we don't have to worry about. One line of code like does all of it for us. What I also love about OpenCV is it is Googleable. Like how do I do X in OpenCV Python will get you lots of Stack Overflow answers. And as you know, Stack Overflow can be a challenge, but it's also like a good starting point to sort of explore new opportunities. So it's very nice in that regard. There's lots of people working in it. So as I mentioned, some of you have already said like, hey, I use JavaScript. Like how different is that from Python? And Python's pretty similar. It's what we would describe as loosely typed, which just means that like you can change a variable to a string, integer, or floating point without getting lots of error messages. The biggest difference, and the one that people fight about the most, is that Python is white space dependent, meaning things are tabbed under each function. So you have to make sure that your white space is set up. And many of you will probably get a white space error at some point. We'll sort of see. The other big difference is you might be used to using lots of curly braces or semicolons in JavaScript, and pretty much you never see that in Python, which is nice. So it's like Python looks much cleaner, which I sort of like. It's a little bit easier to read because there's less like just stuff everywhere. But you have to keep in mind that that white space is important. Sublime Text will usually format your white space correctly for you. Most code editors, once they know it's a Python file, will do their best to make sure your white space is set up differently or set up correctly. But I do find that sometimes copying and pasting from other people's Python files and bringing them in will cause issues because of that white space. Long and complicated is Python can read either spaces or tabs, but it can't read both at the same time. So if you have, 2 spaces equals a tab, and then you're mixing that with like a 4 space equals tabs, you're going to get lots of errors. So for this class, we'll mostly be typing out pretty simple commands, so it shouldn't be that big of an issue. But if you do run into it, one of the nice things about this is like errors happen all the time, and your job is just to sort of like figure out what the error is and work around it. So that's what Lee and I are here to help with if we can. So here's a great example of just sort of like the difference between JavaScript and Python. So in JavaScript, you do have to sort of say let or var, and then give the variable a name, and then you say equal to this. In Python, you don't need to declare like the variable or let beforehand. You just say name equals, and it figures it out. So you could switch name from a string to a integer to a floating point without running into any issues. So this is where you'll commonly see the biggest differences is in how you format stuff. So in JavaScript, this is what a for loop kind of looks like. You have curly braces that open and close the function. Technically, this tab isn't required in JavaScript, right? Like you would just like stick the print right here and it'd be fine. It looks ugly. No one does it because it's like really hard to read. But technically, it's not required. Whereas in Python, it actually is required. If you don't have your tab between the function, the for loop, and the print statement, it will throw an error because it literally doesn't read this as part of the same function, part of the same for loop. So this is the most important thing to remember. Once you get the hang of it, it's fairly straightforward, but it is important to remember that, you also just can't type in like space, 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 and then do space, space somewhere else. Like you want to use a tab. Tabs are the cleanest and easiest ways to just make sure you're formatting it correctly. Functions also look a little different. You usually have to do function and then whatever your function name is, and then a bunch of curly braces, and make sure you remember semicolons. I guess semicolons are less important these days in JavaScript, but most people are still like pretty stringent about using them. In Python, again, it's a little bit cleaner. You use a lot of colons instead of semicolons, or I guess colons instead of curly braces. But these are the same ways of writing these functions. So we'll do a lot of function writing in this just because it does help sort of format our stuff a little bit more. So you'll get used to this format hopefully in the next couple hours. As I mentioned, like sort of the tools we'll be using is some sort of code editor. Again, you can use Sublime Text, you can use VS Code, you can use whatever the heck you have. Make sure it's a code editor though. If you try to use TextEdit, you're going to run into a bunch of issues with formatting. And then another important thing about Python is running scripts. So basically, like these always run in an environment. So this is what we use Anaconda for. We'll go through a couple examples of this in the first session. You can usually run scripts directly from VS Code or Sublime Text. I prefer running them directly from the terminal, directly from the command line, because that way I know they're in the right environment. You might run into issues with environment settings and those sort of things directly out of Sublime Text. Some of you probably have a really like awesome setup that does environment handling through VS Code or whatever. Have at it. For this class, we're just going to jump between our text editor and the command line. So all of the code for this workshop is actually already up. I'll mostly just be like maybe cutting and pasting from this work. So you can already download all of this. It's at this GitHub link. I actually recommend downloading it now. Those of you that know how to use Git, just grab that URL and you can go ahead and use it. If you are not a Git person, that is totally fine. You don't need to be for this course. What you'll want to do is just come over to code and you'll hit download zip, and that'll download a zip file for you and you can work directly out of that folder. So there are a couple images that I've already added here. So you'll see in this inputs folder, I've added a couple images just so that we can use that as the base. Obviously, in the real world, we would use thousands upon thousands of images, but because we wanted this to go pretty fast, I've created just sort of like a random set of maybe 5 or 6 images that'll process really quickly for us, but give us an idea of sort of like what happens with horizontal images, what happens with vertical images, what happens with square images, what happens with big images, small images, that sort of thing. So we'll make sure that all of that is up and working for you. Yep, thanks, Leah. All right. So unless there's any questions, we'll go ahead and get started. So we're just going to look at sort of how to do input-output. So the first thing we want to do is just sort of like, how do we read an image? How do we output an image? So the basic structure for sort of pretty much everything we're going to do in this course is we're going to read an image or a set of images as a folder. We're going to do something to those images. We're going to crop them. We're going to rotate them. We're going to, colorize them or something. So we're going to do something to those images, and then we're going to save out all those images into a specified location. So for this session, we're just going to do 1 and 3. So we're going to look at how to read in an image and then how to output an image. So let's actually start with the code editor. So I'm going to go ahead and sort of show you. So all you have to do is, if you have a folder of files, so this is where I always save my code. All you need to do is actually drag your zip file or your Git file into Sublime Text. That just opens the whole thing as a folder. So here we go. So one thing I should mention is, man, how do I turn off linting here? That kind of works. It doesn't perfectly work, actually. All right. Okay, so when you open up your folder, you'll see here that I've got a bunch of files already set up. So there's one that's called Python template. So I recommend using this as just sort of your base. What this allows you to do is it allows you to run a script directly from your command line. And basically, this is already sort of set up. So you've got a thing here that says if name equals main, run this function. So this will just help make sure that your everything works directly inside the command line, as you would expect. So we can go ahead and try this. So we'll just go ahead and type in a really quick print command. So we'll do hello world. And then let's come back to our terminal. So I'm actually going to create, I'm just going to open up a new shell. So for those of you that went through the steps, you should already have an environment set up. I'm going to set up a new one just for myself really quickly. So conda create name cv. Cool. So for those of you that haven't used conda before, you can just activate your environment by doing conda activate and then the name of the environment. So I'm just going to do conda activate cv. So you'll see here at the beginning, it now starts with cv. And the way to run a file is just to, so first off, we're going to go into our paths. We'll grab the path to this workshop folder, and we'll type in here, we'll do cd space, and we'll paste in that path. So now we're inside of the CV workshop folder, and we'll do Python, and then we'll type 00, and then we'll hit tab to sort of autocomplete. Autocomplete is one of the very nice things about these tools. Let's give myself a little bit more space here. Okay. Also, let me know if the fonts are big enough for everyone to see. So we'll just run this. So all we need to do is say Python and then the name of the script file. So hit return. And of course, I get an error message just to start us off. So why did I get an error message here? Interesting. Why did I get an error message here? There we go. So apparently, so I use a linter. It'll mean some of this will look a little janky. Let me know if that is too annoying, and I can probably turn it off. So this just lets us run a file. So all it's saying here is looking for this whole like main section. I honestly never know what this means. I just always use this template. And then from there, it lets us run some code in this function. Yes, you do. I did save the file. So I always save the file, and then after it's saved, then you can run this command. So if I don't make, let me do this again. So if I say print not saved, and I don't hit save, and I come back over here, and pressing up also goes back to the previous command. So if I press up and I hit return, you'll see it didn't get that not saved because I didn't save the file. If I hit save and then I do Command S and then I press up, you'll see now I get saved. So yeah, you do have to save the file. Cool. Okay, so we're going to use this template as our way to get started. So I'll just copy this and go over here, and I'm going to make a new folder in my work just to set up a new folder of live code. So basically when we, after the break of every session, I'll upload this to GitHub so you have access to the exact files that we wrote in this course. We'll go ahead and do live. And so we'll come over here and I will just do this directly here. So take our Python template and we will do, whoops. Just copy that and paste it into live. So now we've got our template there. Okay. So remember that what we want to do is we want to start with, so basically the way I always write this out is I just structure sort of like, what am I going to do here? So I'm going to read in an image. And I'm going to then output an image. Okay, so let's talk a little bit about how we do this. So reading images in, we're going to use a command called cv2.imread, and then we'll do the path to the image. And then saving images out is the same, it's cv2.imwrite, and then you have to feed it the path, the image data, which we'll have used from imread, and then the file type. So we'll look at how to do that in just a second. So let's start with talking a little bit more about, oops, I want to do this. Let's talk a little bit more about what Cv2 is. So Cv2 is a Python, is the Python version of OpenCV. If you've ever used Python before, you know that usually the way you install libraries is by taking that sort of command that imports Cv2 and typing in pip install Cv2. For whatever reason, OpenCV is one of the few things that doesn't work that way. You actually use pip install OpenCV-Python, or if you're using Anaconda, you can use conda install OpenCV. So this is where the environment comes into play. So what we're going to do is we're actually going to go back to our Anaconda window. And actually, this is a really great thing for me to show. So before we do this, let's actually try to import this. So let's say import Cv2. So I'm going to save this file out as O1, call it IO, and we'll save this. So you import libraries into Python using an import command. It always goes to the very top of the page, or almost always goes to the very top of the page. So by default, you might like dig around on Stack Overflow and grab someone's code, and you might see like, okay, import Cv2. So let's go ahead and do this. So let's just see if this works. So if I come over here and I do Python, and I change my file, so it's going to be O1. And I know what is going on here. I need to go into my live folder, so cd live, and then Python O1 tab. So we're going to just run this script, and it should just work for us, right? Man, what is going on with this? Oh, I know what's going on here. It's because you need some function inside of your, or you need something inside of your function. So we're going to just say print testing. Okay, so that worked fine, which is interesting. It probably shouldn't have. Let's see if I try to actually read in a file. So the way this will work is now that you've imported the library, you should be able to just say my image data equals cv2.imread, and then we're going to need to pass it excuse me, a path. And this path is the path to a file. So let's just grab one of our inputs here. So we'll grab this, and really simple thing you can do sometimes is you can just like click on a file here, and you can do CV, or sorry, gonna be stuck with saying CV. So we'll just grab this image. So we'll do Command C. That'll just copy the path of this, and then I think you can just paste it here into terminal, and then you can just copy it. That's kind of the hacky way to do it. Sublime text, depending on how cool your Sublime text is, you might be able to click on the image and say copy as text, and then path as URI. It might not work for you, so I would probably recommend doing this sort of thing of just like copy that here. Yeah, cool. Thanks, Redfoo. And then just pasting the path there, and then we'll just copy this path. So we'll save this file. Another thing you could do is if you just want to go based on sort of the local path, you could do, or relative path, you could do .. inputs. So basically we're inside this live folder. If you want to go back a folder, we just do .. and then inputs and then this command. So that's the relative path if you're interested in just typing that out. So we'll save this, we'll run this again, and this time we should get an error message, but we'll see. Nope, didn't get an error message. Okay. Maybe that means Cv2 comes installed by default in Anaconda, but usually what you have to do is you have to do pip install OpenCV-Python. And what this does is it installs this library into your environment. So we'll just run this just to be sure. Still really surprised that actually worked and isn't throwing errors, but let's see. Yeah, so apparently when you install this using Anaconda, it comes pre-installed. Oh, so you got it. Okay, so Doug got it. So this is, okay. Great that I'm getting, that other people are getting different errors than me. But anyway, if you do get this error, okay, cool. So some people did. I don't know why I didn't. That's so weird. So if you got that error, then all you need to do is type this into your command line, and then you'll get a thing that says, yes, so yep, great. Okay, so you'll type that in. You'll probably get a command that says, are you sure you want to install? You'll hit Y, and then you'll hit install. Yes, and make sure you have import Cv2 at the top.
So I just want to check. I have Conda installed. Should I be using Conda, or is pip going to break things if I use pip?
It doesn't matter. Conda purists will tell you to use Conda, but you can use pip and it works just fine. Yeah. Okay. The nice thing about these environments also is they're pretty isolated from things. So if you break it, the worst you have to do is like delete your environment and restart it. But most everything will work fine. Okay, really interesting. I'm really confused as to why I didn't get that error. Oh, okay, so how to make a live folder. So it doesn't really matter. What you can do is you can do, inside of here, you could just make a new folder and just call it, live or whatever. It doesn't, I did it directly out of Sublime Text, which is, again, I should probably be a little bit better. Also, I should mention, this is the first time I'm really teaching a real coding workshop. So if I'm going too fast or I'm jumping ahead, please just stop me and be like, whoa, slow down, tell me how to do this thing. I am totally down to stop and slow down there. So yes, making a folder, you can just make a folder however you want. And Sublime Text should just auto-update, right? So if you make a folder in Finder or wherever you are, Sublime Text should just quickly copy it. So it's sort of up to you. I'm not going to just copy these folders over because I want to write the code by hand just so people can sort of see how it works. But if you want to make a copy of it and just sort of follow along, you're more than welcome to. So yeah, I should also say, like, if you want to follow along, just watch me and then try to like replicate it yourself during our free time, you're more than welcome to do that. Okay, so we've now read in a file. So what's sort of cool about this is you can actually sort of see, we won't get too deep into this just yet, but if you wanted to sort of see what is about the, or like how would you look at this image data? So we could do image data, and then we could do .shape. And what .shape says is like how big is this file? Like what are the dimensions of this image? So we'll go ahead and just hit save here, and we will do print image data shape. And so what we outputs here is it outputs 480, 720, and 3. So what does that mean? So what that means is the image is 480, I assume that's height, by width of 720, and 3 channels. This is RGB. So if this were a PNG with transparency, it would be 480, 724. So there would be an R, a G, a B channel, as well as a alpha channel. So we'll use image data shape a lot more in the future when we start to play with actually like figuring out the dimensions of images and cropping things. And also I should note that depending on how stuff is set up, you do get some nice hover states and other things to reference images. So we'll play a lot more with image data. One thing to note is that by default, OpenCV reads in images as BGR. So we probably won't do any like color effects or anything in this course. But if you do mess with that in other places, make sure you're aware that it's actually BGR. Miguel, if you wouldn't mind just posting your error in the chat, that way Leah or I can take a look at it. So while we've read in yeah, so Eli, what you want to do is if you do that pip install OpenCV-Python, that'll fix your issue. And for Miguel,
I think you need an equal sign after image data.
Ah, yeah, that's what it is.
Mm-hmm.
So image data equals that equal sign.
And Ryan, you should put quotes around inputs. That's the PNG. So it'll be like cv2.imread, open quote, inputs, .png, close quote.
Yeah, so go ahead and keep dropping stuff in there and Leah can respond. We're just going to look at also how to write out a file. So what I'm going to do here is I'm going to make a folder. So I'll make it inside of this live folder. So I'll make a folder called outputs. So we'll just do outputs. So this is where I'm going to drop files for now. We'll look at how to do this smarter in the future. But for now, I just made a folder here called outputs. And what I'm going to do now is I'm going to save this image data out. So we're going to do, so come back over here, I'll show you. So what we're going to do is we're going to do Cv2 imwrite. So I'll copy this whole thing here for folks in the chat. So we're going to do Cv2 imwrite. So this is going to write out a file. And it's going to say, where do I want to save this? So we'll give it a path. So paths should pretty much always go inside of either single quotes or double quotes. I usually use single quotes because they're a little bit cleaner, but you can use either. And we're going to want to say outputs / and then we'll just give it a name real quick. So we'll say output.png. And then image data is already this file. So we're going to take this data that we've read in, we're going to save it out. And then the last thing we need to do is we need to give it a file type, which I can never remember the ending for this. 1 second here. So the input is this. So we're going to use this, which is, let me just paste it in here for everyone. So we're going to use in square brackets, you do cv2.imwrite _png compression, (0). I'll paste this in here. So Eli, are you getting an error message when you try to run pip install inside of
it says that the requirement already satisfied. Open.
Okay.
Yeah, then yeah. I can paste what I'm getting.
Yeah, if you don't mind, yeah.
Yeah, I think that's easier.
Why would you be getting that, but it still won't work? So then you still get the no module name cv2.
Yeah.
Interesting. Okay. Maybe you and I can work through this during our working session. Yeah. Sure. Sorry about that. Cool.
No worries.
Yeah, of course. Okay, cool. So we've now got this imwrite command here. So we've got outputs / output. I'm just going to copy this whole line here so people can copy and paste it. It's probably easier than trying to write it out by hand, huh? Yeah, so we're going to use that command. So what this is going to do is just going to write out our file for us. So we'll go ahead and save this file. We'll come back to terminal. You'll find that like one of the most common things you do is just bounce between these two windows. So get used to that command tab or whatever switches your window function. So press up once to get us back to running this command. And we should now, if we look back in our folders, we should have an output file, right? So we wrote this out. So Emily's question was, should it be .. /outputs? So because I have the outputs folder directly inside of the live folder, yeah, so I put it there. If you were to put your outputs folder out here, you would need .. /outputs there. So I'll put that in here. So this is the first time that we will this is probably the last time we'll do this manually. We're going to automate this code really quickly, just to make it a little bit easier for ourselves. Okay, so clearly writing this for every single file we do is going to be pretty annoying. So we're going to skip that. So starting now, like what we'll start to do is we'll use a tool called argparse. And one of the nice things about argparse is that it allows us to start to automate or start to add what we call arguments from the command line here and bring them into this tool here. So I'm just going to copy a bunch of code because the truth is you don't really, it's just like, I'll walk through it, but all I ever do is copy and paste this code. I never write it by hand. So I'm going to drop it in the chat. So we'll be using this code. So after our Cv2, we're going to hit return and then hit another return, and then we're going to paste this code in. So I'll walk through this code. Again, I never write this out myself, so I don't think anyone else should have to either. This is a thing called argparse. So one other thing we have to do before we do this is we're going to have to, at the top here where we do our import statements, we're going to do import argparse. So argparse is a library that comes with Python. So you don't have to do any pip install. You do, however, have to at least type in the import statement. So by default, Python brings in, a certain number of tools, but if you want to bring in other things, you have to use the import statement. So we're going to do import argparse, and then we pasted all of this code here. So let's talk a little bit about what this code is. So we created a new function. We're going to call it Parse Args. That is basically going to say, what we're going to do is we're going to parse the arguments that are coming from the terminal command, and we're going to figure out what each of them means. So by default, you'll do something that says parser equals argparse, argument parser. This is rather confusing, and it sounds like you're just I don't know, creating some sort of riddle. This just defines that you're going to use an argument parser in your command line. We give it a description. This just helps people know what it does. And then you pass in a bunch of arguments. So each of these arguments uses sort of similar functions. So basically what we're going to do is we're going to give it a short name. We'll show how this works in just a minute. So if this is confusing, I promise it'll make sense once we show how it works in the command line. So we're going to give it a short name, a full name, the type of input. So this is actually where you need to define what input type you're giving it. So for this, we're going to actually feed it a path. So paths are always strings. So we're going to feed it a string path. I often will provide defaults in case you don't, in case you don't want to automate or change this value. You will add in a default. That way, by default, it always runs this. It's nice to give helpers. So this is a bunch of helper functions. Again, what I generally will do is as I add each of these, I will just copy and paste these. So you'll see me just copy and paste these and edit these. At the very end, after we've defined all of our arguments, we're going to run this thing, which just basically says we're going to parse all the arguments that come in through our command, and then we'll return those arguments. So this is the function for this. And the last thing we need to do is we need to, in our main command, we actually need to run this command. So what we're going to do is we're going to type at the very top here, instead of main, we're going to type arg equals parse args, and you'll see it like allows you to autocomplete. And we're just going to define that as a function, and we're going to close it. Oops, and I see I did minus instead of equals. So what this says is when we first run this function, we're going to take all of the input from our command line, and we're going to parse it out and use it in various ways. And this should be args, not arg. So what does this look like? So what it means we can do is in the command line, we can do this, and then what we can do is we can actually provide paths and other arguments into the file from here. So we'll do -i space, and then we'll copy a path. So let's just copy this single image path, and we'll paste this in here. So now we're saying our input is going to use this path, and we want to give it an output. So let's say -o, and our output is going to be outputs slash, we'll call it argparse underscore test dot png. So we won't run this command because it's going to throw an error because it won't throw an error actually because we're just not doing anything with these values just yet. So what we want to do next is, I should mention, the short names that we're using here, you can use either the short name or the long name. So this would also be correct. You could also type -- input or -- output. The full name always uses -- the short name always uses a single dash. So what we want to do now is we're going to make sure that we actually can use these values. So here we've got args equals parse args. So if we just print our args and run this command, this will show us what all of our arguments are. So we'll go ahead and add this print statement here, and we'll put it at the bottom of o1_io. We'll hit save. Come up and hit up. Oops, I want to leave this here, and we'll hit return. And you'll see here that it spit out input equals and output equals. So what we can do now is we can use these arguments in our file command. So what we'll do is we'll use, instead of this path, we will use args.input. So this will always reference whatever we input here. And then what we can also do is we're going to replace this path with args.output. So we can remove this print command because we know what we have. So we're parsing our arguments from the command line, and then we're reading in the input path that we provide, and then we're writing to the output path. So if we save this file, and we come back over here, and we press up, what we should see when we run this is we will see a file in our outputs folder called argparse_test. And sure enough, there it is. So now we've hooked up argparse, which means like we're gonna play with this a lot. We're gonna use argparse in a lot of ways because it allows us to, instead of having to manually edit our code every time, it allows us to pass in variables directly from the command line, which is gonna be huge. Like it's gonna let us to manipulate folders and a bunch of other things. So pretty powerful here. Any questions before I jump into reading in folders? Invalid character in identifier. You know what? I would check to make sure that those quotes are straight quotes and not curly quotes. Sometimes one of the problems when you paste in code into like the chat is that it converts things to incorrect quotes. So maybe double check that first. Did anyone else get the same error as James? Okay. Well, let's see what happens here. Dan, which last string? The command line or one of these from here?
Just the command line. Just having trouble reading it.
Okay. Yeah, of course. Yeah. So your paths will obviously be different, so make sure you so your input path will definitely be different, so make sure you swap that
I do have a question. What happens if you, like, as the output, like, specify like a JPEG when we're saving it as a PNG? Like,
Yeah, I think it'll just it'll technically be a PNG under the hood, but it'll have a file name of JPEG. We're going to solve all that in just a minute. We're going to write a function that allows us to do JPEG or PNG. But for this, it's just a little bit easier to write it out here. But yeah, we'll definitely cover that in a second because that will get pretty gnarly pretty quickly. Unrecognized arguments, HT users. Oh, so I think, Ryan, I think you passed it the folder and not a single image, which we will also fix in a minute. But right now, you need to pass it an actual image. If you pass a folder into args.input, Cv2 doesn't know how to read a folder. It only knows how to read it in single images. So pass it a single image instead of just a whole folder. We'll cover that actually next. It's a great segue into our next session. Yep, great, cool. So actually, Dusk, this is a great point. So let me just copy this code. You can get this from the file that is o1b_io_folder. So I'm going to paste this in here. This is a function that allows us to save out images depending on the file type extension. So what we're going to do is we'll paste in this code. So also, James, I should add, you can grab this from the from any of the test files. So if you just want to copy and paste from there, that's probably easiest. So if you look at o1a_io file, you should be able to grab that code. And Nauko, one thing I would also mention is make sure that your folder path is correct. So make sure you have the outputs folder inside of live, and make sure that you have here outputs and not like a slash or a dot or anything. That's another thing we'll fix in just a minute, which is basically that if this folder doesn't exist or it's in the wrong place, it'll fail silently. One of the challenges of Cv2 is a lot of things fail silently, which they think is good, but for us is actually a challenge because then we can't figure out what's going wrong. So yeah, so we'll make sure this folder path works or exists, I guess. Okay, so we've added this function called save image. Again, this is a function that I pretty much use all over the place, and I just copy and paste it. Yeah, so we've got a save function. What save image will allow us to do is it's a function where we can pass it the image data, we pass it a path, and then we pass it a file name, and we pass it an extension, and it figures out everything from here. So we'll look at how to build this up in just a minute. So basically, if it's a PNG, we're going to save out a PNG file using this. And if it is a JPEG, we're going to save it out using this command. So you'll see, if you want to Google this, you can look up like cv2.imwrite, and there's probably like more functions that you can pass out for, like, I don't know, if you want to save something as a TIFF or something else, you could probably try that. So yeah, there's different options here for saving out images. Cool, okay. Fahad, would you mind explaining a little bit more about what you're asking for?
Yeah, so I have a folder with all types of images, like they're JPEG, some are PNG, and so on. And I want to like get a print of all of the extensions I have in that folder.
Cool, yeah. So we'll talk about that in just a minute, but definitely. The nice thing about our sort of imread using Cv2 is that you don't need, it doesn't really care about whether the input is a PNG or JPEG. It figures it out, which is kind of nice. But we can look at how to print out all of our folder files in just a minute. Okay, cool. So we've got our save image file here. So let's actually rewrite this imwrite to just use that command. So what we're going to do is, instead of cv2.imwrite, we're just going to do save image, and then we're going to start to build up our results here. So the first thing we want to do is we want to do image data, right? So we're going to save out our image data, and then we need to pass it a path. This will be the wrong path at the moment, but we'll fix that in just a second. So args.output is we're going to pass in as the path. Remember that right now this is a full path, meaning it has the PNG and the extension on it, but we're actually going to want to give it a folder instead of an image path in the future. So we'll give it a file name. So this is where maybe we would say test.png, and then we would also add the extension. So we want to save this out as a PNG, and then these go in brackets. So this basically replaces this command. And this will allow us to maybe say test.jpg and JPEG. That's how we could save that as a JPEG. Okay, so let's look at how to read in a folder. So if you look at o1b.io underscore folder, you can also grab this code. We're going to use yet another library, and this library is called OS. So at the very top here, we're going to add an import statement. We're going to say import OS. The OS library allows us to move through paths. This is essentially operating system. It allows us to sort of look at various pathing and that sort of thing and work off that. So what we're going to do first is let's read in a folder. So we're going to say, so let's actually look at what we would do in terminal here. So what we would do is we're going to press up, and instead of the input going to an individual file, we'll have it go to that folder. So we will just remove the path that points to an individual image, and we'll just leave it as a folder. And then our outputs is going to be similarly only a path. So we'll just do outputs. So now what we need to do is we need to make sure that when we read that that we actually are working off of a folder. So what we'll do is we will say, I'm just going to comment this out for a second, and we will say files equals os.listdir, and then we'll pass it args.input. So what files will give us is it's going to list everything inside of this folder now, because we now have sent our args.input as a folder. So this will basically now say okay, give me every single file inside of that folder. So then what we can do is we can write a loop here. So we'll say for file in files, and then we'll say print file. So what this is doing is, let me give us a little bit more space down here. So we'll say, so we're going to say for every file name inside of this variable called files, this is a list. It'll be a list of files. We'll say for file in files, print out the file. So what this is going to do is it's just going to give us a list of every single file inside of that folder that we pass it. So let's save this, and then I'm going to actually comment out the save image, just so that we can just look at what we're getting out of our file. All right, so we'll run this command now. I'll copy this into the chat for everyone. Remember, again, your input path is probably going to be different than mine, but I bet we could fix that by just doing should probably just be ... inputs. Try that. That should work because everything's relative. So I just ran this, and you'll see all it does is it spits out every individual file that is inside of that inputs folder. So Fahad, I think this should answer your question, that you'll at least see what's JPEGs and see what are PNGs.
Is there a way that I can see that in a set? Like, I don't want to see the files themselves, but I want to see a list of extensions that are in the folder.
Yeah, that would probably be something like what you would actually want to do is you would want to say file.split. Yeah, basically what you would want to do is you would want to say something like if file.split, and then you would split it at at the period equals, JPEG. Actually, you'd want file.split, and then you would want from the end. Then you could do something off that. We could also chat about this during our break if you want to talk about more of what you have in mind. So this is a JPEG. Okay, so we now have 4 files in files. We have our file name. And so what we're going to do this time is now we're going to take our CV image imread. So we're going to say image data equals. And instead of this time saying args.input, we're actually going to take in file. So we're going to read in our file data. And we're going to then, from here, we'll then save out our image. So we'll do this. So now we're looping over a folder, right? So we're reading all of our images in from a folder. And then we are, for each of those files, we're reading this in, and then we're saving this out. This is going to throw an error. I'm just going to tell you this now, and we'll fix that in just a second. But maybe start to think about why that you think this is going to throw an error. So we'll go ahead and hit up, and we'll check out our error message. Yeah, so we'll see, if you see something that says assertion failed, image empty and function imwrite, that basically means there's no image data to write. So if you get this error message, that's fine, we'll fix it. So if you recall, when we ran print on our file, save that, we'll run this and look at it. Why did that not save? Why is it not printing? Okay, we'll comment out our save function here. And we'll just get our print. So if you see, file is only giving you the file name, right? It gives you the file name and the extension, but not the full path. And remember that we need the full path in order to be able to actually read in an image. So we're going to need to do something a little bit fancier, which is we're going to do a thing called os.path.join. So what we will do is we'll type os.path.join. And then what join takes is a folder path. So we'll give it a folder path, which will actually be args.input. And then it combines it with a file name. So what we're going to do here is we're going to, this will basically give us the folder name plus the file name, which will be the full path. So this is one of the challenges, is trying to keep all this wrapped around in your head. So I'm going to go ahead and paste this here. os.path.join, args.input, and file. So we can actually add this to our print statement, and this will give us the full path. And then when we run this, we should be able to see the full path directly out of terminal. So here we go. We get now the full path. So now we can use that in imread. So we'll come back here and we will go imread, and then we can save this image out. And remember that we are saving this out as args.output. And then the challenge here is that we don't want to predefine the extension, because if you look at save.image, we're actually combining the file name and the extension together. So here again, what we want to do is we are going to make sure that works correctly. Oh yeah, you know what? This works fine. So we can actually do this. Sorry, I didn't realize I wrote this code this way. So if you're confused by this, what we're doing is we're actually splitting out the extension. So there's a thing called os.path.split extension. And what this does is actually removes the extension from the file name. So when we pass a file name in here, it's being split so that basically we're taking whatever the file name is, removing the extension, and then adding our own extension back in. So what we can do here in the save image is we can now pass file in as the file name. And as long as we pass an extension in, it doesn't matter. Like, we're just sort of going to get sort of what we want out of it. So let's go ahead and try this. So let's go ahead and hit save. And we'll hit up, and we'll hit return. And if I look inside of my outputs folder, I should now see all of my files saved with the correct file name, and they're saved as JPEGs. Any questions about that? Okay, so one thing you might also notice is that right now we're sort of saying this is inflexible, right? We're now saying that the input has to be a folder, or where previously we had the input have to be a file. So this is where you might write an if-else statement, right? So you might say, if file is a directory, let's make sure that we actually, let's do this process. But if it's not a file, or if it's not a directory or a folder, then we want to do something else. So the way to do that is to, again, type in, so an if statement. So if os.path.isdir. So this says if my file is if my path is a directory, and then we'll pass in args.input. So it says if my input that I provided is a folder, then we want to do all this. And remember that you'll see here, I'm starting to get an error message. Because we're using an if-else statement, we need to indent all this. You can select all this code, and at least in Sublime Text, if you hit Tab, this will move all of your code in line. So now I've got an if statement that says, if this is a folder path, then let's do this command. And let's write our else statement. So else, so that would say if it's a file, then what we want to do is we want to read it in as we did previously. So we'll read in our image data like this, and then we'll save out our image data like this. And you've got a little bit of a challenge here because we have to figure out how to split off our name. How would you do this? I'm trying to think about how you would do this. Probably the easiest way to do this would just be so name equals args.input dot split, and you would split it at the slash, and you would do -1. Anything that's in a bracket and it says dash, or sorry, -1, that means from the end. So this would basically give us the file name split at every single point of the forward slashes, and then we would get just the file name. So let me get pass name in here. So it took us 45 minutes to get set up with like a input output. I promise now that we've got this set up, it'll be a little bit easier to like go forward from here. Yeah, so definitely. So Leah brought up the point that like I should definitely go over all of this and summarize all the code. This actually sort of wraps up the first session. So I would say like if you're struggling with this, please let Leah or I know, and like we can spend the next like 20 to 30 minutes helping people out. For those of you who are very familiar with this or like comfortable with this, this may be a good time for a break. So why don't we do this? So first off, what I'm going to do is I'm going to show sort of like what we can do next in terms of challenges. And then what I'll do before we wrap up and break out into breakout groups is I'll summarize all the code that we've done here. So let's go and take a look at our challenges. So again, the challenges are sort of like for folks who are definitely code familiar. If this was a bit of a challenge for you, all of this code, it might be good just to sort of refresh what you're doing, and then also reach out to Leah or I to sort of talk more about, maybe get help here or there. So for those of you where this was sort of a cakewalk, or at least you're able to follow along fairly easily, maybe over the next 20-30 minutes, a challenge you can think about is, right now we're only looking at a single folder, right? So if there's a folder within a folder, we've got some issues there. So how do we work with that? So there's a tool called OS Walk that you can Google and you can start to play with and sort of see how that works. So maybe try writing some code to maybe solve for that, right? So let's build up a folder. You can basically duplicate the inputs folder and put it in another, we'll say Turducken, have an inputs folder inside of an inputs folder, and see if you can iterate over all the images in there. And then I think Fahad was sort of saying at this is like, what if I want to limit my file types? So what could you write as a command that maybe would look at only JPEG images or only PNG images. Does that make sense? Cool. Okay, so those are sort of the challenges. So Leah's going to help set up some breakout rooms. Really quickly, why don't I go through like sort of all the code we wrote in this session so far. So the first thing we did is we set up a couple imports. So you want to make sure that you are using the OS library, the Cv2 library, so this is OpenCV, and then argparse. So OS allows us to traverse paths of files. Cv2 is obviously what allows us to read in and write out images. And argparse allows us to do some of that parsing from the command line. So this function controls all of our argument parsing. So this allows us to sort of keep track of what people are typing into the command line and be able to do something with that. This command is saving out images. So this allows us to save out images as either a JPEG or a PNG. And this main command is where we're starting to do some of the good work. So let me clean this up a little bit. It's a little messy. So, and sorry, during break, I'm going to turn off this linter because I know it's getting crazy annoying. So I'll make sure it's a little bit cleaner and easier to read. The very first command we did is we're going to parse all of our arguments. So this is going to take whatever we took in from the command line, and it's going to allow us to sort of break all those pieces in the command line into arguments we can use, right? So we're going to read in the inputs, we're going to read out the outputs, those sort of things. Once we have that, then we need to check, okay, did I get a folder path provided to me as the input, or did I get a file, like an image file as the output, or as the input, sorry, input, output, give me trouble there. So this first command looks at, okay, if I was given a folder path, then I want to do everything inside this block. If I was given a single image as a path, I want to do everything inside this. So let's look at just what happens inside the folder path. So if I'm given a folder path, the next thing is that you will need to parse all of the files inside that folder path, right? So we're going to look at, let's take that folder path and then let's use os.lister, which just gives me every single file inside there. So one thing to note is that if you have something that isn't an image file, like a .txt file, you'll run into some issues with that. And I'll show some code on how to fix that after our break. Maybe that's another challenge for people who are interested. Once we get our list of files, then we want to say, okay, so for every file that is in this list of files, here's what I want to do for each of those. So we can comment out the print because we don't need that anymore. So we're going to take in that file path, and we're going to use os.path.join. This gives us the entire file path, right? So we need a full file path in order to read this in to read in the file. We're going to save that image data into a variable called image data, and then we're going to save out that image, and we're going to save it. We're going to take the image data, we're going to save it out to our output path, and the name that we want to give that file that we're going to save is going to be file. So it's this variable. And then right now we're saving these out directly as a JPEG. So you could switch this out to PNG. Another thing that might be cool for you to try is how would you take or how would you rewrite or add an argument to your parse arguments that saves out a PNG or JPEG. So that's another thing to think about trying to do. So we're going to save that out. And it's pretty similar for if we have a single file, so we don't need to worry about our file loop. We just need to grab the image data. We do need to do a little bit of parsing here in order to get the correct name out, and then we can just save the image out using the exact same file. Okay, so that covers everything. So what I recommend we do, let's take 20 minutes. So Leah and I can work with individuals who maybe struggled or ran into errors with their code. For those of you who are a little bit more code savvy, maybe try some of these challenges. I'll post them in the chat for anyone interested. This is also a great time for a break, so you need to get up and take some water. Go ahead and do that. So Leah, you want to set up our breakout rooms?
They're already set up.
Okay, perfect.
Yeah, I gave people the option if you want to return to the main session, if you have any questions. I think like before, yeah, you can all go to your breakout rooms if you feel set. And if you have a particular error, I think Eli might have, you can hang around here before going to your breakout room. Cool. And yeah, with that, I will open up the breakout rooms for 20 minutes. And yeah, if you like have a burning question, you can hang back or also come back to the main session whenever. And also Derek and I will be hopping around to help you guys. Okay, opening the breakout rooms now.
Thank you, Dusk. Okay, so in this session, we're going to look at resize, crop, and pad. And I actually think this session might go a little bit easier because there's less code to write. So hopefully it'll be more like just conceptual things and less like lots of code writing. Fahad, do you have a question?
Yeah, I worked on the problem I had before as a challenge. The problem which I'm having is actually when passing images through a pipeline, for example, an augmenter, I get a problem with like images that are more than 3 channels. And I don't know how to find them and remove them because I web scrape and I use a lot of images just to test out like StyleGAN a couple of times. Yeah.
Yeah, let's look at that. Why don't you and I chat during the break, our next break, and I'll show you show you how to do that, because I think that would be pretty easy to actually filter out. Cool. Yeah. Yeah. Of course. Great. Cool. So let's look at resize, cropping, and padding. So now we sort of like we have our pipeline here. We're reading in images and we're saving out images. And now what we really want to do is the fun stuff of just like what are we going to do to those images, right? So we've got some options here, right? So we can resize images. And when we talk about resizing, there's things like, do we want to scale an image by like a multiplier, or do we want to have a fixed size? We can look at cropping images, right? Do we want to crop images? How do we crop things? Is it consistent size? Is it a variable size? Those sort of things. And then when we talk about padding, we're talking about adding either borders or other things to our images. So that's what we're going to look at in this session. So let's start with resizing. So we're going to use the Cv2.resize command. And what this takes in is it takes in your image data. So what is currently your image? And then it takes in, when you see parentheses like this is what's called a tuple. It basically is, it's kind of like an array. I always tend to think about everything as like arrays in JavaScript parlance. So this is a tuple of a width and a height. So we're going to take in our image and then we're going to give it a width and a height. And then we need to give it an interpolation method. This is like in Photoshop when you resize. When you resize things that are like bilinear or like nearest neighbor or other things. So this is the exact same sort of idea, and you pass in an interpolation method. So with that in mind, how do you get this width and height, right? So this is the sort of the key thing that we want to assign to our process here. And there's a couple ways you can think about this, right? There is a scale factor, right? So we could say like multiply this times 0.5 or like make it 50% smaller. You can use a fixed number, like let's say like I want to make all of my images 1024. The fixed number is also an interesting question of like, do I want to do that on the long side, the short side? So this gets kind of complicated, like actually writing the code for various, what's the process that I'm actually doing and how do I outline that, or how do I let someone else decide like, oh, I want to make this 1024 on the shortest side, or I want to make it 1024 on the longest side. These are sort of complicated questions. So for this session, we're only going to look at using a scale factor because it's fairly easy. It's actually a fairly easy process, but maybe a challenge would be if you're interested in using a fixed number, you could try that during our breakout session. Okay, so let's take a look at this in the code. So as a reminder, I have duplicated the O1B folder and have renamed it crop and brought it into my lives folder. So if you just look here, you'll see I now have a folder called O2 crop. This should probably be, let's just rename it now. Let's call it Resize. So we'll do O2 Resize in live, and I just duplicated this file, so O1B IO folder, and brought it into live. So we'll open this up. You'll see here, like, again, I covered what little changes are here, but for the most part, we're ready to go. So the first thing that we want to do is we want to sort of like decide, like, okay, we need to define like a process, like what process are people using on these images in order to do this. So the first thing we're going to do is we're going to add a parser argument. So we're going to take this parser argument, and let's just make sure that my code wraps here. There we go. So we're going to take our parser argument, and we are going to add a new one. And we're just going to do -p, and then we'll do -- process, and we'll give it a string, and by default, let's just say resize. And now eventually this is going to be resize crop or pad. So basically what we're going to do is in our command line, we're now going to add an additional process of -p, and then we'll be able to assign various processes we want to apply. So now what we want to do is when we before we run our save file, we're going to actually need to determine what our process is. So I'm going to only work in our folder path for now. So we might need to like copy and paste some stuff into this command once we're ready. But for now, let's do this. So for now, let's just say, let's create a file, a command or a function called process. So then we'll come up here, and above define main, we will add a define process. And what we're going to pass into the process is the image, the file name, and all of our arguments. This is a pretty common thing. We'll just like pass around our arguments from here into all of our file commands. So let's set this up. So we've got process here. So we'll pass in our image. We will pass in our file name, which in this case is called file. And then we'll pass all of our arguments through. And we're going to comment out save image because we don't need that just yet. So up in process, we will do if args.process. So remember, we're taking process from up here. So we'll say if args.process is equal to resize, and then we'll pass that to a command called resize. And just as before, we'll pass image, we'll pass file name, and we'll pass args. So we won't, like, this feels kind of like an extra step at the moment, but for now, like, we'll eventually fill this out with cropping, padding, and a bunch of other things. So let's add yet another function here. So we'll call this define resize. And this is going to take in the image, the file name, the args. For those of you who are coders, you probably know that there's a cleaner way to do this. In Python, there's a thing called KW args you can pass around. But this is probably like simple for everyone to remember. Okay, so now in here in our resize function, what we're actually going to do is we're actually going to we'll like do the resize function, and then we'll save out our image, right? So we're actually going to take out this exact same path here, which is not right. So here's what we're going to have to do. So we don't need this either. We're just going to process the image here. And then we'll actually take that out path and we'll move it into this. So the out path is still going to be using our args and our file name. So we're going to, let's just assign this variable above. So what is our resize function? So as I mentioned, it is cv2.resize. And then if we go back to this file, we'll see it is our image data, which has been passed through as image. So we'll do img. And then we need to provide our dimensions. So what I like to do is I actually just like to I'll stick in some fixed values for now. So let's just stick in a fixed value of 100 and 100. And then what I need to do is the interpolation, which I can never remember. So I'm going to pull this from another file. Which is this. So I'm going to paste this command into our chat. So if you need it, you can use this. Oh, and one other thing I forgot is we need to save this back to our image variable, right? So right now, if we run this, this isn't being saved anywhere, right? We're resizing it, but we're not saving it to a variable. So what we're actually going to do is we're going to overwrite the image variable to be saved here. So we're just going to say, like, take the image data variable, resize it, and then save it back to image. And what I'm doing here is I'm just going to force it to a fixed 100 by 100, which is going to be squishing the image in a weird way. It's going to like squish everything and squash it. But this will just help me know that it's it's working the way I expect it to. What I tend to find is I tend to write a lot of little bits of code and then slowly build up my process so that it doesn't get, basically if you write out everything all at once and you get errors, you don't know where in your path the errors happened. So let's go ahead and run this command. So remember, this is the O2 resize. So I'm just going to come back over to my terminal. I'm going to clear all this out. Command K clears out your terminal. I'm just going to empty this. So I'm going to say Python, and it is, you know what I also need? I need to do live, cd live. So I'm in my live folder. So I'm going to do Python, O2, then I'm going to press tab, so it auto-completes the resize. And what I need is I need an input folder, so I'm going to go ahead and copy my inputs. I do like to use absolute path. I find absolute path is a much safer way in instead of trying to remember the dot slash or dot dot slash. So I'm going to give it my full path. I'm going to give it a place to go out. So I'm going to say outputs. So now I have my input path, my output path. What else do I have in my argument? I have a file extension, which defaults to PNG, so I can just leave that as is. And then the process type defaults to resize, which again is fine for now. So I can just leave this as is. So if I hit return, let's see if I get an error message. I do get an error message. So what I get is a, so on line 42, I get an error message that says name file is not defined. I think I know what that is. So if you recall, I changed file to file name as I was passing these variables around, which is a very common mistake that I always make. So we're just going to switch file to file name, and that should fix it. So I'll press up and rerun this and see if this works. I didn't get any error messages, so that's a good sign. So let's go ahead and open up my Finder window. Sorry, I'm going to close all these out so that we don't, so you can still see some of the code. So let's squish this over here. And if I go to live and then I go to outputs, I've got nothing in here. So something still didn't work. Okay, so let's figure out what happened here. So my outputs, so one thing you can do is to make sure that you actually have image data to write, you can do print img, and this will just like let me know like, or actually let's do this, let's do img.shape. So again, shape returns the like height, width, and the output of, or like the channel count here. So let's run this and make sure we actually are getting images. We are. So there's something here about our output. Oh, you know what it is? I see exactly what it is. Or maybe I know what it is. See exactly what it is. Let's try this. So let's do print out path. Let's make sure that this path is correct. Okay, so we should be getting an outputs path. All right. Farhad asked, do you need to return the image? You don't, because I'm just saving the image from here. So let's do this. So basically one thing we can do is if you feel like your imwrite is working incorrectly, we can just hard code this and make sure that like, maybe something wrong with the save image function. So let's try this. Let's just say, where do I want to write this to? I want to write this to my outputs path. So I'm just going to hard code this in /test.jpg. And I'm going to read that image, and let's just see if this works. Nope, nothing. Interesting. Let me look at my notes and see what I'm doing wrong here. Okay, let's try this. So we've got our image here.
Is it because it's a JPEG and not a PNG, and you're not, you don't have that condition?
Possibly. Let's just dump out all of these variables and make sure we're not doing anything really stupid here. An output path, a name, and we have a PNG. You know, I'm going to try something here, which is, I don't think is the problem, but maybe we're overwriting the wrong variable. Or like we shouldn't be overwriting the variable. Seems like that'd be a silly reason for that to not work, but let's just see.
Eric?
Yeah, go for it.
I just put something in the chat box.
Mm-hmm.
I tried printing the os.path.join argument that we provide to I am right.
Yeah.
And it seems like the file name is
interesting.
duplicate.
Oh yeah, that's probably what the issue is, right? Let me just see if that's what my issue is too. Let's remove this. Huh, that doesn't appear to be my issue.
Oh.
But that is good to know on your end. I think maybe that's because I wonder if you passed it. You might have passed it a single image. I don't know. That's interesting. James, maybe we can look at that in a minute. Let me try to figure out what's going on here. You know, this is one of those things where like live demos never go the way you expect them to. Okay, so let's just skip this completely and see if we can just save this image out from here. Okay. Let me try something else here. What is going on? Okay, let me take a look at my own. Let me try to work from my previous code, which is All right, well, good news, I guess. My current code works fine, or my previously written code works fine. So let me try to see what might have happened here. I can't imagine that forcing the image to 100, 100 is what's wrong, but let's try this. So if we come back to this, into O2 resize. Yeah, that's what it was. So Fahad was right. The issue was, or sorry, James was right. The issue was that I was providing this out path as both the file name and the output, and that was wrong. I have no idea where that why that happened the way it did. But essentially, man, sorry, that was really confusing. So this out path is wrong. What we needed to do is just replace it with just args.output. So James, sorry to tell you were wrong when you were right. Yeah, so that's what the deal was. Sorry, wow, that took way too long for this class. But as you can see, like I screw up all the time too. So the fix for this is at line 40. You want to switch this to this. So save image args.output file name, and then args. Whoa, that's the wrong. Let me send it to everyone. This here. Yeah, sorry about that. So just switch out path to args.output, and then you can remove that out_path function. So cool. So let's just run this one more time. And this should produce. That's interesting. Why is it not producing a bunch of squished images for me? Oh, of course. Now I know why. So one thing I'll note here is, yes, I'm saving the original. Yep, exactly. So I saved this out as a different variable, right? I was previously doing image equals. And if I do that again, this will work fine. But I had changed the variable to resized, and then resize was going nowhere. So that was what the issue was there. And if I come back over here now with that new variable there, and I go to outputs, you'll see all my images are squished to 100, 100. Okay. So we clearly don't want this, right? Like this is this is not a way to make a data set. So what we really want to do is, for this, let's try a scale factor. So what this would be is if we multiply it times 0.5, we get a 50% smaller image. If we multiply it times 0.75, it gets 0.75. If we were to do larger, like 1.5, we would get a larger image. So let's define a scale factor. So I'm going to hard code this in for the moment, and then we'll turn it into an arg parse variable in a minute. So let's just say scale equals 0.5. And what you want to do here is you want to get the shape of the image. So let's say, so what you'll do is you will do, and I can never remember the order of this. So you'll do, we're going to take a tuple back. So we're going to get height, width, and this is going to equal image dot shape. And this is a little Numpy thing we'll talk about a little bit more. This is called a slice. So we only want the first two variables. So you remember if we print out image.shape, if you remember this gave us back three values. It gave us back a height, a width, and then a channel number. But what we want is we just want the height and width. So actually, Fahad, this is where you could start to look at getting just the last value. I believe it would be -1, would give you just the last value for your channels. But yeah, so this time we're just looking for the height and width. And then we're going to multiply these values times the scale to get back our new values. Now, if I recall, one of the challenges here is that This tuple is width by height, but image shape gives us height by width. This is a thing I find very common in OpenCV, is that they like flip the orders for some reason. So you want to make sure that you're doing the right thing here, which is that you get width times scale, and that you get height times scale. So what are we doing? We're taking the current image height and width, we're multiplying them times a scale factor, and then we're resizing to those values. So one thing that I tend to do a lot is I'll just like print out these sizes to make sure I have the right ones. So it might be print W times scale, and then print height by scale. There's one trick here, is if you multiply an integer times a floating point, that converts it to a floating point number, right? So the problem is that this is looking for integers. So if I run this, and I'll show you how, if I run this now, it'll throw an error message. It'll say integer argument expected got float. So what we need to do is we need to do what's called casting. The simplest way to cast is just to type int and then wrap the number itself in parentheses. There's lots of other ways you could do this. You could do round, float, or floor, ceiling, whatever. This is just the simplest way. So all this does is like it throws out whatever the floating point value is and just converts it to an integer. So if we pass it these integer values, now make sure that whatever value is here is an integer. And if I save this and I run it again, that's interesting. What did I get? An error message there. Something tells me, here we go. Yep. My parentheses are wrong. Is it right? I think this is right. This is right. I hate making sure all my parentheses are in the right place. This is correct. Yeah. So basically the issue there was I had Sublime Text tries to guess where you really want to put parentheses, and it often does it wrong. So now we have this wrapped, we have a tuple wrapped in integers. And if I press up one more time, you'll see it's spitting out floating point values. And you'll see here, this is a great example of why sometimes just multiplying by a scale factor is wrong, right? Because we're getting a 0.5. So we're actually doing a little bit of squishing, right? There's a little bit of loss in that image change. And that just happens with a lot of this. And hopefully our interpolation knows how to interpret that. So I'm going to remove all these print functions just so it's a little bit cleaner. So that's scaling. So if you've ever messed with like the Dataset tools library that I do, you'll know that most of the time we scale by a value. Like you pass in a pixel value and it scales by that. That might be a challenge for those of you interested in working on that during our break. But yeah, so like this is the easiest way, right? It's just multiplying these shapes by a value and resizing that way. Resizing by other functions is a little bit harder because you have to check to see which value is longer, and then you have to do some sort of like guessing the ratio and that sort of thing. It's a little bit more of a challenge. Because I want to cover some more topics, I won't cover it here. But if you are interested, there's lots of ways to play with this and do more functions with this. Any questions about resizing? Cool. Let's move along to cropping then. So it turns out that all these things sound really simple, like when you try to think about them, but then as you try to do them more programmatically or at scale, these become a lot harder. So cropping is another one of those issues, right? So let's say I want to crop these two images, and I have a size, like let's say I want to crop them to like 400 by 400. Like, well, how do I go about doing that? One option is I could go from the top left, right, and I could just crop down. Another option would be to crop from the center. So even when you're building these tools, even for yourself or for other people, you have to sort of think ahead about like, okay, but what are they actually trying to do? Like, where are you actually trying to crop an image from? So this is one of the challenges. So we're going to look at doing a center crop, which means we have to add a little bit of math in here to sort of figure out where the center is and then crop from there. Cropping from the top left is actually far easier, but I think it's probably less what people actually want to do. So we're going to look at crop from the center. Cropping uses a tool called Numpy slices. So remember that our image data is a bunch of rows from the left, or from sort of like reading left to right, that is the width, and then top to bottom is the height. So what we're going to do is we're going to use a crop using image, and then you look at the pixel array essentially, and you go start to end, and you use the colon as a way to signify between where you're starting from and where you're ending from. So if you see something that is like 0 to 480 here in one of these array indexes, is it saying I want to go from 0 to 480? So that's all that the colon represents, is I want to go from 0 to 480. A lot of times people won't put the 0 there, and I'll just say colon 480. And if you don't see anything there, that means from the beginning. So that means from 0 to 480. So if we want to actually look at this, thank you, Leah, for fixing these slides. These slides are really great. So if we want to actually view this, say, in our own images, and we want to do a crop that was 0 to 480, 0 to 480, this is what we would look at, right? So we'd say start at 0, 0, or start at 0 and go to 480, and then start at 0 and go to 480. And if you're going to do it from the center, this gets a little bit more complicated, right? Because first you have to figure out how far in am I going and starting from. So let's say it's 120, and then I go 480 pixels from there. So it would go 120 to 600. And then from the top, it's like jump down 60 pixels. And then from there, you go down 480. So this is how cropping works inside of OpenCV. And it can take a little bit just to sort of like wrap your head around the right order. Like I actually think, I'm also trying to remember, I guess the way we've done it here, I think this is right, Leah, is it starts with height and then it goes width, which I believe is correct, yeah. OpenCV, you would think XY, so usually you think width and then height. OpenCV flips that, and it's very confusing and often leads to a number of problems. So yeah, just remember order, like if you start to get crops that like flip weird, it's usually that. Okay, cool, so let's take a look at this in the code. So first thing we're going to do is we're going to come down to our process, and we're going to add an additional process. So let's just duplicate this, and we'll say if, and then in Python, instead of if else or else if, it's just elif, which again is, who knows why they decided elif. So we're going to say if not resize, but instead, let's say crop. We'll add a new process type called crop. So we're going to write out the function for this. So let's say define crop. And again, we'll pass in all the same variables. So image, file name, args, and we'll hope that we don't have an endless stream of errors here again, where we're going to pass out save image. So we're going to do the cropping now. So again, let's start by just hard coding this in. So let's look at a crop where we say crop equals, and we'll do image. And let's just, let's start with something really simple. So let's say image to 300, and then 0 to 300. So this will just take a 300 pixel crop from the top left. And we'll make sure that because we're changing this here, we're going to change out our save image. So let's go ahead and just make sure this works as we expect it to. So we will come back here, we'll hit up, and we can use all of this again. I'm going to change the output folder, so I'm going to do output-crop. This is the thing that I tend to do a lot when I'm debugging, is I just like dump things into new folders all the time, just so I can make sure that like they're working the way I expect it to. And the other thing we need to add here is we need to change our process type. So by default, the process was resize. So we're going to do -p, and we're going to pass in crop. So let's just run this, see that it works the way we expect it to. We didn't get any error messages, so that's good. And if we go back to our Finder window, we will see we have a new folder called output crops. And from here, we can't really tell what this is, but we do see it is 300 by 300. And it looks to be correct. I could go through those images and check to be sure, but I'm pretty sure this is right. So this isn't really what we want to do, right? Like we don't really want to crop just from the top left. So let's try to do a center crop. So with center crops, the challenge is that you need to figure out what the absolute center of the image is and then crop from there. So with this, we're going to take our height and width functions, and we're going to save these as variables. So we're going to get our height and our width, and I'm just going to write these out as variables. You could probably do it all in one function in this variable if you wanted to, but I find it's a little bit easier to just, like, when you're breaking these down, to start thinking about how to like save each as a variable. So let's say center x equals w divided by 2. So again, remember, the way to find a center is just to like take the height, divide by 2, take the width, divide by 2. The challenge here again is that we can't really work with floating point values when we talk about pixels. So we're going to do the int casting again. So we're going to cast these to integers. So we've got center x, we've got center y, which will be int of height divided by 2. And then we want to pass in, so again, let's just hard code a square crop or a patch size. So let's just do patch equals, let's say 480. So again, we're just going to take a 480 patch from the center essentially. So the way to do this now is, where do we get start x? So start x is how far from the left we want to start. So you probably can figure this out, but you want to take center x and you want to subtract, right? You want to go to the left half of the width. So path, or sorry, that should say patch, not path, patch. Patch divided by 2. And because of it, I will always over parenthesize just to make sure that all of my stuff is correct and you don't get divisible errors, like whatever, what is that thing? What's it called, to like order of operations? I always forget whatever that is supposed to be. So this will give us our starting point. Yes, PEMDAS, thank you. Yep. So this will give us our starting point. Our ending point is essentially, there's 2 ways you could write this. You could write center x plus this, or another, sorry, you could just say start x plus whole patch. Both of those are the same value. Because I've hard coded this value in, and I know it's something that's divisible by 2, I don't really need to worry about like casting this to an integer. So yeah, so that's the x value. And then if we want to do the same for the y value, so start y equals center y minus patch, and end y equals start y plus all of patch. Okay, so now we have all of our values here, right? So now we can just go in and start to add these as a part of our slices. So again, remember that the image is height by width. So you start with the y values, and then you do the x values. And this should give us our values. So let's go ahead and run this. Okay, so even though I said you don't need to worry about this, apparently you do. My guess is that even though these are floating values, like with no actual float, like it's 0.0, you probably still need to cast all these to integers. So let's just do this just to make NumPy happy. So I'll cast all those to integers, and now if we press up and run this again, you didn't get an error message, which is a good sign. And if I come over here, I see these are now 480. And they look to be cropping more from the center. I could probably double check, but I'm like fairly certain this is right. So all these crops work. Now, one thing I will note is that if we look at the inputs on these files, none of these images are smaller or like larger than, I guess the smallest size for these I believe is 480. This one happens to be 720 by 480. If you make this value larger than that, let's make this 600. You will get some actually let's make this really big. Let's just make this 1200. You will get some very funky things going on as you begin, because the crop is larger than the image. So because of this height and width, you're going to get some really funky values going on. So let's just run this and see. It's important to note that you will not get errors. Python doesn't, or like NumPy and OpenCV will like just be like, cool, that's fine. I can do this math. And you'll get negative values, which means it actually takes from the beginning. So it is cropping, or it does weird crops when your request is larger than the image it can actually handle. So like some of these worked fine because they're really large images. Other ones did all sorts of weird things. So this again is like, what do you want to do with that? As a programmer, you could put in a check that says, if the patch size is larger than either of these dimensions, either don't crop it, or like resize it, make it bigger, and then crop it. Like, again, as you begin to build out all these tools, you have to sort of figure out what to do with that. I will leave that up to you to work on in the various like tools or whatever you're going to build during the breakout session. So maybe think about how you might work around that or fix that. So folks who are not getting saved images out, can you make sure that 58 says the first argument you pass in says crop? I believe by default we just copied and pasted and it said image. So make sure it says crop because we changed our variable for the crop to say crop. And I will also add that make sure your folder exists. So if you didn't add this function or if you didn't start again from the, yeah, so let me show the terminal. That's a good point. So, okay. So the command is, again, I did absolute paths, and I find that absolute paths are a little bit cleaner to understand or just to wrap your head around. So let me know if this helps.
Derek, can you say the part about line 58 again?
So line 58 is make sure that you're passing in crop and not image, right? Because image is the original crop. Although honestly, this shouldn't affect saving out your images, like because you should just get the full size image and not a crop. I'd also say make sure that your arg outputs is actually being put to an output. So make sure that you have args outputs. Make sure you also have this line that makes the folder path if it doesn't exist. So why don't we do this? If you're still stuck during our break, we'll try. Lee and I can try to debug this, and if not, we'll figure this out together. I've got one more thing I want to show before we go to break. So let me just do that really quickly, and then during break we can help anyone that is having issues getting these to output. Okay, so the last thing I want to show is how to do how to resize or how to like pad images. So what if you need to make the image larger, right? Like let's say we've got a 720 by 480 image and we want to make it 1024 by 1024. One way you can think about that is you're sort of adding a border to the images, right? And that's actually a common technique. A lot of people do that. They'll just add black or white borders to their images and save that out as their data set. And quite honestly, that's how OpenCV thinks about it too, is you're just adding borders to an image. But you've got some options around exactly what your borders look like. So first off, the border command is Cv2 copy make border. And again, you pass it the image, and then you pass it how many pixels you want to add to the top, how many pixels you want to add to the bottom, how many pixels you want to add to the left and the right, and then a border type, which we'll talk about in just a second. And then if your border type is a solid color, you need to pass it a color. So let's take a look at what border types we have available to us. So there are 3 border. Oh, Jen, that's a good one. Yeah. Okay. I'll come back to that in just a second. I've definitely done that many times. Okay. So part 2. So let's look at what our borders actually are. So these are what's called constant values. So we'll look at how to implement these in just a second. But you've got 3 sort of options for borders. The first is you've got a solid border, right? So you can just give it a border constant, which then requires a value or a color value in the BGR set. So if it's 25500, that is blue, not red. Really important to remember. And you pass it in using value. You also have the option of replicate, which just takes the edge pixels and stretches them. And then also you have border reflect, which takes basically the image and reflects it to the borders. So these are all of your options for resizing. I actually tend to use the reflect a lot because I think that, especially for abstract images, you don't really notice it that much. Replicate is good, but it does sort of create this like sort of pixely side depending on how much you're scaling up. And then border constant is also really helpful. One cool trick I'm going to give you that I do all the time is I save out all of my images. Like when I want to resize stuff and I don't actually have pixels to resize to, I save them all out with a solid border of 100% green. And then I write a little Photoshop action that selects 100% green, like a green screen. And then you use the context aware fill to basically fill in fake data. So this is a cool little trick. I've talked about it before. If anyone wants the Photoshop action, I can save it out and share it with people. But it's a really cool trick. And it's a nice way to combine, like, I love, this is where Photoshop does things that OpenCV can't do, and OpenCV does stuff that Photoshop can't do, and you combine those two in a way that is like a really nice approach that you just can't, like, you can't replicate with all these tools. So it's a nice little pipeline to make some nice new data images with new borders and things. Cool. So let's take a look at how to write this really quickly. So I think the first thing, I think this is what Jen was mentioning, is that when you write your elif statement in process, make sure you swap resize for crop. This is a common thing that I do all the time. So we're going to do this for pad. So let's add another command for pad. We'll do pad. I was actually doing this all the time when I was writing this code, is I would just replicate this, and I would never change this command. So make sure you do changes to a new command. So do pad, and then we're going to write in another command here. So we'll do define equals pad. So define pad. And again, we'll do all the same things we do, which is pass in the image, the file name, and our arguments. And we will also pass in the save image command. And then here's what we're going to do. Let's define some border constants. So I'm going to paste this from one of my other commands here, which is, let's grab this. Okay, so I'll paste these in the chat in just a second. So here are the various types of borders. I've defined this, God, this is terrible. I should stick to one variable typing. So let's do border type. So border type, here's how to define this constant. So we'll do replicate. This is, again, the stretching of edges. This is border constant, and this is border reflect. So I'm just going to pick one of these. We'll just do border reflect for now. And then the command we want to write is, so we're going to say padded image equals cv2 dot make, or sorry, copy make border. And then what we need to do is we need to pass it our image, and then we're going to pass it a bunch of values, which we will just define in a second. So top, bottom, left, right. And then what else do we need to define? We need to define the border type. So we'll pass in border type. And because we're using reflect, we don't need to worry about our color value just yet. But if you do, I mean, you can pass this in and it'll just ignore it. So value equals C. So when you use border constant, you value equals C, and I've already predefined a color. This is bright blue. So if you want it to be green, you make it 255. So I always have to remember that I'm in BGR color space, which is insane. I don't know who uses BGR, but it is. So just remember it's always in BGR. So if you start to play with color values, we'll find that like your colors get weird if you don't remember this. So let's just run this really quickly and make sure that our borders work. So this should give me reflected borders. Last thing I need to do here is I need to give this, give these pixel values. So I'm going to hard code in 100, 100, 100. Do not ask me why sometimes they use a tuple and other times they just paste in values. This is the fun of like all these like legacy code environments. I'm sure there's a reason why these are not tuple values or other things, but you have to pass these in individually. This is going to add 100 pixel borders to every side. So let's go ahead and run this. So we'll change out our process type to pad. And I see already I'm going to get an error message. I see already I'm going to get an incorrect output. So make sure you swap out padded image for save image here. One way to just like fix this for your own sanity is to just always replace your variable with just image equals. But I wanted to make it clear that like I'm saving out a new sort of type here. So I'm just going to do padded image. So now we'll just run this and not get any errors. So that's a good sign. Oh, you know what? One thing I just overwrote a folder. So let's switch our outputs to our folder to outputs-pad. And if I come back to my Finder and I look inside outputs pad, you'll see it just reflected my edges. And if I change this, so let's just change one of these variable types. Let's do constant. So I'll uncomment the border constant and comment in the border reflect. Press up again, and let's just do pad-constant. And here we go. Our image has bright green borders. So one thing you'll also notice is that because all these images are different sizes, you will get different sort of proportions here. So maybe that's another thing you might want to do in like a more coding challenge is like, how do I make those variable, like, you know, or like, how do I make them appear the same size, that sort of thing. Or how do I make them a percentage of the various dimensions? And lastly, we can look at the replicate, which is just going to stretch our borders. So that just takes the last row of pixels and stretches them. Cool. Any questions about that? And so you'll notice like I've sort of stopped passing all these through argparse. Maybe a challenge for you if you're really excited by this and want to start building your own tools is, you know, how many argument variables do you want to define to manage all of these various pieces? It can get pretty complicated. Maybe you want to start passing them in as strings and then split out the string into like various pieces. There's all sorts of funky little functions you can do to sort of start to work with that. Okay, so we're going to take another break. Let's do another 20 minutes. Obviously, coding has taken a little bit longer than expected, but let's do another 20 minutes, and then we'll come back and we'll finish out some of this work. We've got one more section that we want to cover, which I think will be fun for folks. So if you're looking for some challenges, we talked about a couple already. So we talked about like we scale by a factor today. What if we want to scale by a fixed number? How would we go about doing that? If you want to crop from a fixed point rather than like maybe the center, how could you define a fixed point? Like always crop from this particular point, or a location, right? So how do we say top left, bottom right, those sort of things? What if you want to make all your rectangular images square? That's the thing that I built into the Dataset tools library. Is like, how do you define? Okay, make this rectangle always a square. And then lastly, this is something I actually haven't solved yet in my own library, which is like, what if you wanted to do a resize and a crop together at the same time? The way I sort of do it is you just run two functions, right? You run one command, then you take that folder and change that to the input and then run it again, which works, but it's probably would be nice if like some of these common functions could be combined in a way that was simple. So maybe you want to think about how you could combine some of these functions as an output. So that's it for our challenge. So if you, again, if you ran into issues and you still aren't able to save out your images, maybe stay in the main channel and Leah and I can help debug. And then we'll go back into breakout groups. So if you want to sort of just chat or hang out, you can go ahead and do that. So Leah, if you don't mind setting up our groups again.
Yep, they're all set up.
Cool.
Cool. I'll open them up right now for 20 minutes.
Great. All right, so those of you that were stuck and aren't able to save out your images, did we figure it out? Did we not figure it out? Where are we? Okay. Nowco, would you mind sharing your screen and maybe we can just look at the code and see what's going on there? recording to make sure I don't forget again. All right, hey everybody. So we have about 30 minutes left, which I think is just enough for me to cover the next material. I was originally planning that we would cover this material and then have another breakout session, but that probably won't happen just because of time and like me having errors in my code and whatnot. But yeah, I really appreciate all the feedback folks have been giving me. We'll definitely make sure that we build in more time for pauses between all this stuff. Another thing is, like, I know that this is, for some of you, like a little fast, and I totally understand that. My hope is that the recordings, which you'll get in a couple hours, feel free to watch those recordings and pause where you need to, you know, take it a little bit slower at various points. And lastly, we do have the OpenCV workshop channel in Slack. So if you have questions like a week from now, a month from now, and you're like, hey, I'm coming back to this thing and I have no idea why I'm getting this error, please post them there. And Leah and I can sort of answer it as need be. You're also welcome to email me with any questions you have. I'm happy to just sort of like try to help debugging. You know, the hardest part with debugging is just like, it's usually just easier to share your screen and walk through it. So if in the future people want to do that, I'm happy to set up a little bit of time for those sort of things. Yeah, so I know that we put a lot into this workshop. We sort of like doing a lot of stuff all at once, but my hope was just that you would learn some things. And then again, maybe you're learning, oh, this thing is available, and like Derek did it too fast, but now I can walk through it slowly with the recording and sort of like figure stuff out myself and then learn it that way. So we will also be sending out a survey at the end of the class, and you should be as brutal as you want to be about all the feedback. If you're like, Derek is the worst live coder on earth, I will not disagree with you. But, you know, so please give us feedback. We want to improve these. We're going to try to do more of these sort of workshops, which are, you know, a couple hours on one topic and working with code as a way to do some things. So like, I've got a plan to do this with looking at StyleGAN and just looking at how to interpolate the values coming out of a StyleGAN model. So just playing with the vector latent space. So we'll look at some code on how to do that. So we'll probably do that, and we're trying to do maybe these like once a month or so, because they're a big ask for Leah and I to sit around for 4 hours on a weekend, and for you too. So if you have other topics or other things you would like us to work on, like, we would love to sort of hear your feedback on that. Something about doing one around the StyleGAN latent space. I'm also considering maybe doing one around importing your own models into Runway. So I know lots of people have wanted to bring in their own models into Runway. So if you're interested in that, I will definitely think about doing a session like that. So feedback on how poor or good this session was, but also future coding sessions you might want are really, really appreciated for us. Cool. So with that, let's jump into the last session of this workshop. So we are going to look at edge detection in this. So, you know, so far we've sort of like explored some like fairly straightforward techniques, maybe things you could do in Photoshop if you have like a really smart action or something. But now we're going to look at a little bit more of the power of what OpenCV is, which is edge detection. So edge detection is really, really cool in that, like, it does some really crazy math stuff that I can't even begin to explain to figure out where all of our edges of images are. And this is really helpful in a couple cases. So we're going to look at canny edge detection, which is a way to draw like 1 pixel lines around our images. If you've taken one of my classes or have seen anything that's like pix to pix, which is like edges to cats or like drawing things, canny is a great tool to generate those outlines. So we'll look at doing that, and then we'll also look at using thresholding as a way to actually crop images. So we'll look at some ways to do that in a second. Most edge detection processes follow the exact same order of operations. So the first thing we almost always do is we convert our color image to grayscale. We then usually do a little bit of blurring to those images to remove any noise, right? If you think about a photograph, there's always a little bit of grain in those photographs. And what we want to do is remove some of that grain. So we'll add a little bit of like Gaussian blur usually. And then we run our edge detection process. And these edge detection processes are built into OpenCV and allow us to do some cool things with like 1 line of code, which is really, really nice. So let's start with canny edges. So canny edges is a process that creates these thin pencil-like edges. So these are almost always 1 pixel.
Hey Derek,
yeah, go for
are
it.
you meant to be sharing your screen right now?
I am meant to be sharing my screen. Thank you.
Okay. Yeah.
Hit record, share the button, do whatever you want to do. Yeah, thank you. I appreciate that. So let's take a look at edge detection. So I covered this really quickly. I don't think it's anything new for anyone. So canny edges look like this. So basically always draw 1 pixel lines around your edge. So as I mentioned, this is a great thing for some like pix-to-pix where you don't want to hand draw every outline of a shape, but you might need to play with the values of canny to get those outlines correct. And that's what we'll look at here. Make sure everyone was yelling at me, weren't they? Yes, they were. Thanks. Cool. So we'll take a look at how to do canny edges. So the first thing you want to learn is just like, we'll go through the process of converting our images to grayscale, which will use this cv2.cvt color, and we'll pass in the image data, and then we'll pretty much always use cv2 color BGR, because remember our images are almost always in BGR format, to gray. So if you're used to using Photoshop where you have a little bit more black and white customization, there's probably ways to go in and like sort of change those to like emphasize blues or emphasize other colors. I generally just throw in this one, which is the default, which converts things to grayscale. I think it just like takes all the values and there's an algorithm that compresses them to grayscale. So once we've converted our image to grayscale, then we'll use blurring. That uses a tool or uses a command called cv2.gaussian blur. And then you pass the image data, and then you pass an amount. And this amount is, you might have used Photoshop's Gaussian blur, and there's like an amount of blurring, and that's usually a pixel value. One thing to note about the Gaussian blur inside of OpenCV is that you're going to pass in a tuple. So it'll be like 5, 5, or 3, 3. The number must always be an odd number integer. This is one thing that always trips me up. I always try to set it to 4, and then it's like, nope, not a 4. It has to be a 3 or a 5. So you'll always want to make these an odd value. That's gets into some of the weeds, but there's an idea of this kernel, a convolutional kernel, and those convolutional kernels are pretty much always odd numbers. So yeah, make sure that you use 3, 5, 7, 13, some odd number. Once we've converted our image using a little bit of blur, then we want to actually run canny edges on it. And that's as simple as running cv2.canny. And behind the scenes, there's doing like a Sobel filter edge detection. There's using like some math. There's using a ton of math to generate this. So it's pretty great that we can do this in one function. So we'll take a look at how to do this next. So I'm actually going to pick up from our very last file over here, which was O2CPad. So I'm just going to copy from this. So I'm just going to duplicate this file. Actually, let's just do this directly in Finder. It's a bit easier from there. So we'll take O2CPad, which is from my code from that I wrote over the week. I'll paste it into live, and I'm going to rename this O3 edge. So O3_edge. And let's come back over here, and we'll edit this. Leave it about that width. View. Word wrap. Cool. Okay. So to get started, I need to add another process here. So we're going to take all this code and we're going to write one more new process. So let's do elif, and we'll do args process equals canny. And then we'll write a new function called canny. And so let's add that down here. So we'll take this and we'll rewrite this as canny. And we'll take our save image and we'll save it. Okay, so now the process we need to do here is we want to convert to grayscale. And then we will blur. And then we will run the canny. So let's start with convert to gray. So if I come back here, we'll do so we'll convert our image, which we passed in as image, so we can remove the image data. So we'll just make it image. I'll go ahead and copy this into the chat as well for folks interested. So first thing first, we're going to take our image data and we're going to convert it to gray. So one thing that's also nice is when you're doing debugging, one thing I find really helpful is actually just save these out to make sure it's doing the right thing. So we're going to add a save image command, and we're going to append to the end of this file name. we're just going to append dash gray. So what this is going to do is when we save out the image, when I run this on my folder, it's just going to save out a bunch of images. And they're going to append with gray. So I'll be able to see how it converts to gray. So I'll save this, or I won't run this just yet. Let's do the blurring as well. So let's come here, let's grab the Gaussian blur. And one thing I should note is I need to actually name this correctly. So we're going to call this gray. So we're going to save this to a variable, say gray equals this, and then we'll save this image out. And now my blur image is going to be equal to Cv2 Gaussian blur, but instead of using image, I want to use the gray. So I want to take my gray image and I want to blur my gray image. And what goes in here is a value. So remember, this is a pixel value. Because we're just trying to remove some of the noise from an image, I recommend keeping this small, like 3 or 5. So we'll try 5. Remember, if we really wanted to blur an image, we would do like 99 or something. But because we just want to remove some noise from an image, we're going to keep this pretty small. So let's do 5, 5. And similarly, I'm going to save out this image. I'm going to pass in the blurred image, and I'm going to save this out as blur. So let's run this, and we'll just sort of see what our images look like. So come over here, and we'll press up, and we want to, let's change this out to canny. So we'll change out our output to canny. So our input will still be working off the same input folder, and our process will be, we're going to use canny edge. So we'll use canny. So if I hit return, you'll see I have a new output folder called outputs-canny. If I come back over here, I got nothing. That's interesting. Let's figure out what I'm doing wrong here again. I wonder if it's because of this. So let me just print our file name here. Oh, I bet you I know exactly what I did. Canny. Huh. Okay, canny.
I know what's going wrong. I think the plus dash gray and dash blurred is getting cropped off because it still has the .png or JPEG, and those are getting cropped out in the saved image.
That's what I thought too, but then when I did print file name, I should at least get the file name. What I figured out, while you were talking, is that I'm using the wrong file. So up here, see how it says O2 Resize? This is the wrong file. I should be using O3 Edge. So for those of you who haven't used Terminal before, in Mac at least, you can use Option Click, and that will point your cursor where it needs to go. So if you Option Click and then point there, we'll switch this out to O3, edge.py. So this should actually use our updated file. I still might have that error dusk though, so let's take a look at that and see. Okay, so the good news is that we are getting, my file name is being output correctly. So it means when I add dash gray, I should be getting the right thing, but let's see if this actually gave me some images here. It did. Okay, cool. So there's our gray image and there's our blur. And it's really hard to see. You don't see much difference. You can kind of see it in the dot of his eye, that it's a little bit less sharp. And that's enough where it's just going to like blur everything a little bit and remove some of the noise, because remember, we're working on an edge detection method, and edge detection looks for differences between black and gray or black and whites. So if you have some noise in there, that noise is going to look like an edge to these models. So by adding a little bit of blur in it, it's going to remove that. And the last thing we can do here is we can run our canny filter. So we're just going to take this command, and we're going to pass in, instead of the image data, we're going to pass in our blurred image. And then thresh 1 and thresh 2, basically there's a thresholding system. There's like a minimum threshold and a maximum threshold. And quite honestly, I don't know what each of them does. Like there's documentation on how canny edge works. It's one of those like more complicated math side of things. I just know you put in a low value for your first one. So you can put in something like 50, and then you put in a high value for the top one, which is something like 200. This is where you might want to play with these values and sort of see what they do and how they change your images. So yeah, that's like kind of one of the things that like you have just to play with. And we're going to set this to canny equals. I always do this. I have to save these to variables, and we're going to save out this image as canny. And I won't add anything here because this will just give me my final output. So with this, we should be able to run this, and we should be able to get new images. I'm also going to remove my file name here. And it looks like that ran. So we can come back over here and we can look at our images, and you'll see that we have some edge detection. So if I just empty this folder, and then I come back here and I'll comment out my saved for these two. So I just get my canny images back out. And let's come back here and look at our images. So see, it's like pretty good. You know, you get decent edge detection. You know, this one's pretty funny. It definitely found all of the various parts of these images. Yeah, so this is the basics of canny edge detection, which, you know, for 3 lines of code is pretty powerful. Like you can get a lot of cool edges out of this. One thing you might want to play with, so the next thing I would recommend playing with is if you play with the blur size, like let's say make this like 23, the blur size will change like how many edges are really in your image. So come over here and run this. We should get less edges. In fact, we get like no edges. So the blur was too large here, right? You'll see we get some edges, but they have to be really, really sharp for that to show up. So this is far too large of a value. So maybe let's do 9. So here we get less edges. The other value to play with is maybe you want to lower or make this higher. So I believe sometimes I see people use 100 and 300. Again, I don't really know exactly what these values do. I would probably just play with them and maybe decide there. Another nice thing to do is, you know, if you want to compare these, one thing you can do is just change out the folder name. So if you just want to like sort of compare, you can make multiple folders and save each out to just sort of see what you get. So it looks like 100 and 300 gives me less edges, I think. So again, you have to play these values to sort of lock in where you want. So that's canny edge. Any questions? Cool. Okay. We'll move on to the next edge detection, which is thresholding. So the other common technique is thresholding. You probably have done thresholding or maybe at least tried it inside of Photoshop. Thresholding just determines you set a value like a midpoint, like maybe a mid-gray, and then everything that's lower than that mid-gray becomes black. Anything that's higher than that mid-gray becomes white. There's a ton of stuff to play with inside of thresholding. It's all documented here, which I'll grab the link to this and post it in our channel. If you want to play with a ton of different thresholding, there's lots of different tools there. We're going to look at a really basic thresholding, which just like, again, sets a midpoint and just does black and white on each side. So once again, we'll use convert color and Gaussian blur, and then we'll use this threshold value. So the only thing you really need to change here is the threshold point. And again, so these values are 0 is black, 255 is white. So anything in between 0 and 255 will sort of determine what goes all black and what goes all white. So a common place to start is just 127, which is a half midway point. So anything that is like less than half gray will become black. Anything that's less or higher than half gray will become white. So let's go ahead and add this to our functions. So we'll come back over here to process, and we'll add another process function, and we'll call this thresholding. Let's call it thresh. And we'll add a new process, which will also be thresh. And then we'll come down here, and we're actually just I'm going to copy all of the code here from the canny because the gray and the blur are going to be the same. So we're going to keep both those. And then all we want to do is change this out to be thresh equals, and then we'll save out this as a thresh image. And then we're just going to take our code here. And we'll paste this here. And again, we want to use our blurred image as our input. Blurred. And then our threshold point. So we want to set a threshold point. So I'll start with 127. This is definitely one of those things where based on the images you use, you might want to play with this value. This 255 just says what should the white value be. So you'll always have 0 as black. You could set this to be lower if for some reason you want a gray value instead of white. It's sort of up to you. So we'll save this out. And I think we're, oops, and I need to change my function name, thresh. And I think we're good to go here. So I'm just going to change my folder name to be outputs-thresh. And we're going to change our process to be thresh. Why did I get an error here? Thresh. Oh, there's a trick here. The trick is that threshold actually returns two different functions. So the first is, I don't even know what the first is. No one ever uses the first. The second is the actual thresholding image data. So what you'll commonly see Python folks do is they will use underscore to mean like, I don't care about this value. So this just means save this thing to a variable that I don't need to use, and then comma threshold, and then we'll save that threshold value out. So I think this should work now. Yeah, so now it works. And if we come back over to our Finder and we go into the threshold folder, you'll see I have a bunch of thresholded images. So if you recall, some of these images were on black, right? This is on a black. So everything that's black, this is one thing to note is that actually we're doing an inversion. I'll talk about why. The reason we do inversion is for the next step, which is we want to get the contours of an image. Ryan, can you explain that question?
Just that idea of like, oh, I've got to put the underscore here. Was that somewhere in the code, or is that just like you knew that because you knew that was how thresh worked or whatever?
Mostly that. Okay. One thing you can look at is the documentation for image thresholding.
Yeah.
If you actually need to click on this one, which is the function Cv threshold. If you open this, it'll tell you. So here's what it returns. It returns a ret val and a distance val. Again, this is one of those things you just pick up from various Stack Overflow places, but ret val is something that I don't even know what that means, because no one uses that. And then distance is actually a distance function, which you might not know means that it's sort of black or white values, but that's the black or white values.
Yeah, that makes sense. I just want to make sure I wasn't missing anything.
Yeah, totally. Yeah, no, this is stuff that you find sort of from picking this stuff up over time. But yeah.
Thank you.
Cool, of course. Yeah, so as I was saying, if you recall, this is on black. So it's kind of funny. We're doing this thing called thresh binary invert. This is how we map these colors. So we're actually inverting the colors. If you want just the black to black, you could remove that invert. And if we run this again, you will get this, which is probably the more correct version. The reason that I tend to do inversion is we'll look at inversion as we do contouring. Inverse tends to help more for contours because it's getting a little complicated. Contours assume that black is a shape and white is a background. So we have to invert these values. So I'll leave this in. So if you play with this value, you can set this, like, let's set this to be a lower value, which means, like, if you set it to, like, let's say 50, that means anything lower, really low, is going to become, in this case, more white because of our inversion, but it just shifts that thresholding point. So if we run this, you'll see we get, we get different values. So as you play with that thresholding value, you'll get different things. This is another case where it might be fun to just open it in Photoshop and see what Photoshop does, and that'll help you sort of set the right value. I'm just going to set this back to 127. Okay, so now we have a thresholding. You're like, this isn't cool. This is just Photoshop, whatever. But what is cool is the next step from this, which is contour detection. So what contours do is it actually takes those shapes, almost like like the magic wand filter in Photoshop, and it can return the bounding box of that contour, which is going to be really helpful because let's say we want to crop around just these thresholded values, right? So we can start to build crops that are like automatic based on the values of the image we have. So that's what this does. So we're going to take that thresholding data and we're going to use find contours, which is going to return a contour value. I think it's probably easier. This code gets a little complicated, so it's probably easier just look at this in the coding environment and we can work off that. So let's jump back over to code. I know we're about to hit 3:30, so if folks need to head out, that's fine. I might stick around a couple minutes longer just to finish this out. Okay, so thresholding. So let's add, or sorry, contouring. So let's add one more function here. So we'll add one last function. So we'll do lf equals contours. And likewise, I'm just going to copy all of the thresholding code because it's just going to build on top of that. Not very dry, but it works. So let's comment out our threshold value here. And let's do contours. So contours equals. And I'm actually just going to copy and paste a bunch of code from the very last pre-written code file. I'll copy and paste it because it's just pretty long, but I'll also explain what each of it does as we go through it. So, and actually I can tell already that I'm glad I did this because there's another error. So here's what we're doing. So we're going to use this thing called find contours, and we're going to pass in the threshold value. These are constants that I sort of understand what they do, but for all intents and purposes, it's just easier to leave these exactly as is. Contouring, there's a ton of different methods, and this is where I might go in and read more about the find contours thing to understand a little bit more. But essentially what this returns, it returns a list of contours. So it's going to return all the contours of the image that it finds. I don't know what this value is. Clearly we throw it out, so it probably doesn't matter that much. So contours, if we were to just actually we can do this. Let's just print how many contours we find in each image. So len is length. So this is a list, almost like an array. They call it a list in Python, but it's basically an array. So we can get how many contours did this find for each image. So let's actually just comment all this out for now. And let's go back here and run it, and we can look and see how many contours are found. So in one of these images, it found 1404 contours. That's a lot of contours. Some of these it only found 20. So this is the number of basically individual shapes it found. So little pixel blocks. Here's all of them that they found. So what we're going to do in this code is we are going to loop through all of those contours, and then we're going to use this code called Cv2 bounding rect. And what that does is it sort of takes all the pixel values and it says, what's the box around the thing? So, it'll then returns, of course, it returns an X and a Y and a W and an H instead of a Y, X, H, W. I don't know why they keep bouncing these things around. But anyway, it returns X, Y value. So this is, where is the start of the box in the image, right? So the X, Y value. And then it returns the width and the height. So this is a really nice little piece of code that is going to convert all of our contours into little bounding boxes. So what we're going to do from here is, one note is that if you try to output all of your contours in this version, you're going to output 14,000 images because there's 14,000 contours, right? So we probably don't want to do that. So what I have generally found works well is if you just set a max height and a max width, and then you look in the bounding box and see okay, how big is this thing? And for this code, I just set it to be, let me post, sorry, I should have posted this in the chat so that people have it. So we're just looking at how big is, how wide is the box and how tall is the box. So I just set a value of 500 to make sure we only output really large bounding boxes. And then we're using our crop filter here. So again, remember that this is using Numpy slicing. So we take our Y value, so our start Y, and we add Y plus H. So this is the height value. And then we take our width value, so our starting point, our block, and we're saying, just give me just back that crop, right? So just give me the crop of that value. And then we're going to save out that image. So we'll just save out the crop, and we'll give it a file name of -crop. And then because there's potential for more than one, we're using this for loop that uses an I in, so basically you could also write this, I believe probably the JavaScripty way of writing this would be for I equals 0, I is less than length of contours. And then you want to iterate over I plus plus, right? Like that's how you would write that in JavaScript. This is a little bit simpler. It's just saying like, give me I in however many contours I have in this image. And we're going to take that I and we're going to output it as a part of the file name. So we were not overwriting our files over and over again. So we'll just run this line. And we want to switch out our process to contours. And we will switch our folder to contours as well. And let's hit return. And contours is not defined because I didn't rename my function correctly. So contours. Let me make sure it's defined correctly up here as well. Yeah, so contours and contours. So these are the same mistakes I make all the time, Jen. All right, so now we should be able to run this. And let's hope that worked. Got our contours folder over here. So you'll see, in this case, it actually cropped this person fairly well. This one looks like it might not have cropped anything in that image. This one cropped fairly well or so-so. It cropped some of the black from the image on the left-hand side. This is funny. It cropped the person. It cropped his head. It cropped his screens. And it cropped just one screen. And then this one is actually fairly good. This cropped almost entirely the bounding box of this image, right? So if we would go back and look at the inputs, this is a tool that I use all the time in my own work because a lot of my artwork is stuff like this, and I crop around, all of the white space. So this is a really, really powerful tool where, again, doing this in Photoshop would be pretty time consuming. Getting all these contour boxes back would be pretty hard or annoying. So this is a nice little feature that allows us to do a lot more. And as you can imagine, let's say you want to add a little bit of padding to your crop. There's probably some math here you could do to like pad out your crop. So you could put a little 50 pixel border around that cropping. And then you've got a nice sort of bounded padded image. So there's a lot you can do once you've got these contours to actually make your crops pretty consistent. So look at that. I almost did it in time. So that's everything for this course. So basically, we went through just sort of reading images in and out, doing some cropping, doing some padding, doing some resizing into edge detection. And I highly recommend the OpenCV library has a bunch of tutorials. If you just do OpenCV Python tutorials here, I'll copy this link here for folks. There are a ton of different other things you can do. So I think, James, you and I were talking about maybe can we do face detection? Yeah, so there's probably some tutorials here on doing face detection. Let's see. Interesting. Well, we have to dig around. But the tutorials here are fairly nice. You can copy and paste some code in. Now that you've got sort of the basics set up, you could dig in through a lot of different things and sort of find some interesting tools to play with. So hopefully this was a nice introduction, just to get your feet wet into OpenCV. And there's a ton more here. I'd also, again, recommend that you dig in through my Dataset tools library, because you'll see I've got some functions around if I want to pad my images, how do I make sure that it doesn't go outside the image bounds, those sort of things. So there's lots of, this was sort of straightforward in that we added a lot of hard-coded things, but as you begin to build out tooling and that sort of thing, there's lots of opportunities to play with making this a pretty fully fledged tool. So I hope everyone found this helpful. Again, Leah and I will send out a survey. So if you have feedback, things you expected to learn versus things you did learn, feedback for us for next time on how to make this easier on everyone, those sort of things. Yeah, and then please feel free to post questions, comments, other things in our Slack channel. I'm always happy to talk about this more. This is a tool that I love building. I do so much work. I probably spend most of my time building out my tools library for myself to do this work. So if you're interested in more of it or have questions about it, I'm happy to share with you. Yeah, so really appreciate everyone's time today. I know 3.5 hours is a long workshop, but I really appreciate people hanging out, asking good questions, giving good feedback, and hopefully you're making something cool with this. If you do make cool stuff with it, please let Leah or I know, and we're really happy to share that work with other people as well. Yeah, so I'm happy. I'm happy to stick around for a little bit of time if people have questions. If not, feel free to take off and have a good rest of your afternoon. But yeah, I'll stick around for like 15, 20 minutes if people have questions about, how do I do this? How do I do that? So if you're heading out for the day, have a good rest of your day. And thanks again.
Yeah, thank you all.
Yeah. Yeah, so Fahad, do you want to talk a little bit about getting the channels out?
Yeah.
Yeah, perfect. Okay, cool. Let me share my screen. I can show you maybe where we would do this. Cool. So your question was just like, if I want to basically avoid anything that has RGBA, is that right?
Yeah, correct.
Cool. Okay, so let's take a look at this. So where I would probably do this is in my function here, where I'm just sort of like filtering and sorting. What I would probably do is I'd add an if statement here. So let's say, actually, you want to do it after you load the image. So after you load the image in, let's just print out what image.shape looks like. So my guess, I'm just going to comment this out so we don't process any of this stuff. Cool. So see, all of my images end up with 3, but let's do something really quickly. Let me just open one of these and add a little bit of negatives, or like add an alpha channel to it. Okay, so I'm just going to convert this to a layer. Let's just like crop out a section. So then we'll save this. And we'll save it with transparency, and we'll save this into our input folder, and let me just add T there. Cool, so that is there. Cool. So let's run this again, and I think we should see a channel of 4 for one of these images now. Interesting, we don't. Why would that be? Let's check. This is where I go to Google, OpenCV, find RGBA images. All right, so maybe we have to do this. So let's do this. So if you add this to your imread command. So after here, you're going to add Cv2 imread unchanged. So I think one of the things is that I believe OpenCV by default might compress all of your 4-channel images to 3. So let's see if this changes it. Yeah, so there we go. So if you add this to your command, I'll go ahead and paste this in the chat. Cv2 imread unchanged, that's going to say like don't squish this down to 4 channels. And then once we've got this, we can just look at the last channel of our im shape, which I think you can just do with this. Let's see if this works. Nope, that's wrong. So let's just try this. Yeah, so now im shape of -1 gives us our last value. So now we can say if im shape of this is greater than 3, or I guess we should say like if it's less than or equal to 3, then we want to do this stuff.
Yeah, it's pretty much clear. Yeah,
Cool.
I get it.
Yeah, no, that's I would have never thought about that this is the issue until like just seeing it here. So yeah.
Yeah, because mostly like I have thousands of images and I get an error where something is 4 channels, but I don't know what exactly.
Yeah, totally. Yeah, so this looks like this works. Cool. Yeah, that's a fun one. I'm actually gonna have to add that to my own library. I've never even experienced that before, so that's cool.
Great, thanks.
Yeah, of course.
Yeah, I had similar issues. Before this, I was using Pillow to do some of these things, which doesn't have any of the power of OpenCV with the contours and things. Do you use Pillow for anything? I don't see why you would after seeing this, but
actually, people tend to use Pillow a lot when you don't need these sort of tools. So I use Pillow a lot in my machine learning work, where you're just trying to where you're trying to convert like a PyTorch image or a PyTorch tensor to a Pillow image. A lot of people use Pillow in those cases. I think PyTorch has sort of built all that stuff into PyTorch now, so you don't need it as much. But maybe a couple years ago, you used to have to use Pillow for those sort of things. And I think the Runway team, Runway uses Pillow as their inputs and outputs. So if you feed an image through Runway, it's always a Pillow format, and then you have to provide the output as a Pillow formatted image as well. So sometimes I don't use Pillow that often, but you do sometimes come up against like, okay, I have to learn Pillow to like figure this out. So yeah.
Cool. Thanks.
And quite honestly, I probably would have started with Pillow, except I learned OpenCV from a couple people, and I was just like, oh, I guess I'll just start with OpenCV because I know it does edge detection and that sort of thing.
Gotcha. Just with Fahad's question, this was really nice because with Pillow, it wouldn't automatically convert to RGB or to 3 channels. So I had to find workarounds to make it do what OpenCV does automatically. So
yeah, I tend to find OpenCV is kind of like an FFmpeg kind of world to me, where it's just like there's so much you can do in OpenCV, and you just have to like Google it until you get a thing that makes sense. The other challenge is most people respond with OpenCV in their C responses. So you have to also like add append Python to make sure you get the Python response back, and you don't get just C language stuff that is really confusing to read. I do not read C at all, so yeah.
So I do have a question about just your library, because I have a data set of images that I scraped off Instagram, and they all have like weird, like this is like pre non-square images on Instagram. So they're all like, have all these weird borders, and none of them are standard. So I don't know, do you think the thresholding would like, or like, I don't know, doing something like that with the contours would be a good way to like figure out how to crop them, or is there some other method?
Yeah, so I would definitely recommend the thresholding technique. That's actually what I use for, so I have a sort of poorly documented, no, I just have an undocumented tool in here called crop bounds. And this is the tool that I use pretty much all the time. I can sort of show you how it works. It's a little overwritten because there's so many functions in it. So let me just conda activate dataset tools. And let me see if maybe I have one of these commands saved into my history. There we go. Yes, it is. Cool. So this is so crop bounds does pretty much all of this sort of thresholding, but what it also does is there's also a way to rotate things well. So a lot of the images that I work off of look like this. Let me see if I can find one here real quick. So I tend to work with a lot of scanned book images, which means that like, you know, they're on these backgrounds already. And often a lot of times they're like slightly askew, either because of printing or just because I scan them. So this also adds a way to do rotation. So basically the way this command works, I can sort of break all this down into pieces. You give it an input path to a single image. You give it a output path to a folder. There is this thing called, this is something we didn't cover in this material, but there is a thing called dilation and erosion. So what dilation and erosion does is if you have a black and white image, dilation increases the black by a certain amount. So like this is again, what's a nice, maybe I have a different image here that would maybe better show what this would be helpful for.
Is it like expand selection or search string selection?
Exactly. Yeah. Yeah. So it does exactly that. So in this case, imagine this image didn't have a black border, but I wanted all of the data where there's like white space here. So you can use dilation to expand and contract the various like image data. And that's a nice way to like sort of connect some things that are broken up. So dilation is like how many times do you do that dilation? Erosion is how many times you shrink that down. So usually what I find is you have to blow the image up a little, or like expand it a little bit so like it connects all the dots, and then you compress it back down so it stays at the same crop size. So that's what this does. Min size is that threshold, or like what's the max size of this contour that I should look for. Threshold block and threshold size C, there's like, I don't know what all these values do, but there's like some complicated like min and max values of these things. Min is the threshold value, or like where I should, that threshold point. So again, because a lot of these are on whitish backgrounds, I don't use a pure white, but I do something where it's like a partially white background. So it sort of like collapses the white, but keeps every other color that is above that. And then padding is how much padding to build around this thing. Fill boxes is actually, I'll run this on one image just to sort of show you what it does, but it actually draws boxes onto a separate file so I can see where it actually cropped. So I think this is where the Instagram thing would be helpful, is you can play with these values and it'll draw a box to show you exactly that it like covered up exactly what you wanted it to be. And then there's this rotation thing that also will rotate your images slightly to make sure it matches where you need it to be. There's an angle rotation. There's like so much built into this tool, and it's kind of why it's not documented, because it's just like, God, where do I even start? But if anyone's interested in this, I'm happy to start documenting a little bit more. So let me just grab one of these images and sort of show you how it works. This is probably a good one. Also, these images are massive, so they just like take a little bit of time to process. So let's just make sure I save this to the right place. I'm going to use cd repos / dataset tools. Cool. So this will just dump out a bunch of stuff here. And if I go back to the folder where I output this stuff, you'll see that what it generates are a bunch of boxes over images. Now, sometimes what happens is it finds a very small edge over here and I get crap. So I have to like, basically this is what I do all day, every day, is I just constantly edit and clean these things. So I'm just going to delete these folders. You can tell these are too small. But then this one, I can tell already, gave me back a decent box, right? Like that definitely looks like the right image. So I use this as sort of a debug method to sort of see what I'm getting. And then here are the actual images that I get back. So you'll see this one didn't really work as well as it probably should. There's a little bit of edge here that I might need to clean up in Photoshop or in Preview. And the reason for that is if I look at my mask, again, I also dump out all my debug just so I can sort of see what's happening. Because of the edge line on this piece of paper, it created a little box, a little border here. So it just sort of took this whole thing and turned that into a box. So this is, I spent probably a good week or two like building this tool for myself just so I could do this. So yeah, you're welcome to like just sort of grab this and play with it and see if it works for you. My guess is that you'll have to play a little bit with the thresh block, the thresh C, and the min value to sort of dial it in. But hopefully with these sort of like where it spits out all of this stuff, it sort of helps you debug a little bit more to understand like, okay, I see what it converted and I can kind of guess what it's doing, and then you can play with those values a little bit.
All right, thanks. Yeah, that's helpful because I have, I think 26,000 images in this data set, and I'm like going through them all by hand. It's just ridiculous. So even if I can get it down to like 5,000 or something.
Yeah, There's also lots of other. I think there's a class that Leah and I taught a couple months ago on using the Dataset tools library. That let me pull that up for you, because that goes into a bunch of other features that you might find helpful in that library that can help sort of sort. So like maybe like I know with Instagram, one of the issues is that like a lot of the images are really small. So you can also like sort out all the small images, which might help like move like, you know, get rid of all those 640 by 640s from like 10 years ago. And then you might want to, like, once you get that folder, then you might want to run the thresholding on that folder to like, again, narrow it down further and further. So yeah, there's lots of different techniques. And again, there's like probably most of what you would need is in this library somewhere, and it's just probably not documented. So if you ever just like, okay, here's the steps I want to do, what are the things I need to look at, I can happily like point you in the right direction.
All right, thanks.
Yeah, of course. So Tom had a question just about like what size do I scan these in as? So I actually scan them in as really high res. They're all scanned in at 600 DPI. And the reason I do that is because a lot of my images, what I end up doing is I end up doing small patch crops of individual images. Also, I only ever want to scan these one at a time. Like I basically, when a book is finished, I never want to scan it again. So I scan them up really high, and then I have just like a 10 terabyte folder of thousands upon thousands of images. And I run these processes to like resize them and do other things so I can work off those. But I always have the original copies to go back to. But a fun thing to do is there's a tool in here called multicrop. And what that does is basically like you feed it one really big image and it makes a bunch of patches of that image, which is another nice technique for a lot of style again work. So if you have like big abstract patterns that are really high res, you can go in and take different crops at different scales and different sizes. And then you can always like, that actually is a really good way to like train a StyleGAN model, is to do a bunch of that stuff. Esteban.
Hey, Derek. This is definitely an upgrade from the previous course that I took about the data sets. It's amazing, so I enjoy it. Thank you for sharing all. As I said in the private room, I'm interested in creating this tool to combine images, actually to combine two data sets of images, probably 1,000 images with 1,000 images at once. So could you, do you know if I can get some libraries to use these blending tools, maybe like multiply or screen or something? Is that the way it works, OpenCV, like adding these models to use transparency or something?
Yeah, let's see. I believe OpenCV has some filtering methods that would allow like multiplies. Let me just see what exists. Multiply. This is like ridiculous. This is code to like write your own multiplication filter, which I don't think is what we need. Image filtering. Let's see if this is what we need. And I want this in Python, which I can never remember. So image filtering, Python. Half of my job is just like finding the right Google command to get exactly the right page I want. Image filtering, let's see if this is right. Man, this is not. Well, here's an interesting. I mean, I could probably spend days looking through some of these articles, but this looks like a way to actually build like sort of your own Python functions, or like build your own Instagram filters, which I assume is like multiplying and other things. Oh man, why are these so much just about? I don't want to write my own convolutional filters. I want like a multiply paths. There's got to be a way to do this in
Another tool I've been using that I think probably can do it is Image Magic.
Yeah.
which is another like command line thing, and it definitely has like filtering and stuff, but it's like FFmpeg where it's just Googling to figure out how it works.
Yeah, I am kind of surprised there aren't any simple filters in OpenCV. Maybe there are, and they're just like kind of hidden somewhere else or like not really called out. But it might be a case where like image magic or something would work. Also, I would say like processing is probably a good place for that. I know processing has a bunch of built-in default filters that allow you to do that. Let's see, processing, multiply, filter. Yeah, blend mode. Oh, actually, that's what I should look up. Why did I not think about that? Blend mode, OpenCV, Python. So it looks like there might be like libraries on top of these that you could use these. You know, OpenCV is generally like, it's kind of for the data science or image science nerds where like they're trying to like do stuff under the hood. So OpenCV might not be the right tool for this, but I do think something like Image Magic or one of these other layers on top of that might work a little bit better. Or I guess Pillow does this, so Pillow might be a better place for this as well. Yeah, so there's definitely ways to do this. I think it's just like, you know, you need to define an input and folder 1 and folder 2, and then you're going to open both of them and sort of combine them. I would definitely think about looking at like processing for that. I think processing is probably the best like place to start with that, where you could essentially just like take two folders and do that. Yeah.
Let me share just one idea of why, because I want to do this. It's because I generate, as you know, I generate a lot of files in, let's say, Illustrator. And then I have a bunch of files that it was generated with Photoshop.
Yep.
And then I would like to combine them, but it's not possible to do that if I use traditional tools. So that's why I was asking if it's possible to use OpenCV, or probably I should find a different path to solve this situation.
Yeah, I would say OpenCV is probably a little heavy for something like that, but I think processing would be a good place to look at it. Yeah, it's really just about like, how do you save out images? Like basically you just define two folders, you read all the images in those folders. So just sort of like basically what I would recommend doing is like outline all the steps you would see need to happen, and then going and finding the code for each of those individual steps and then sort of adding it together. You know, that's the hardest part, is just like breaking down an idea into like individual steps and individual lines of code and how that like combines up, and like you just have to go through it. Yeah, perfect. Thank you, Dusk. There's definitely lots of ways you could probably do this. I also wouldn't be surprised if like I've got to imagine that you know, Dan Schiffman probably has a tutorial on like every individual piece, and all you need to do is like find all the pieces and combine them that way, which can be a challenge. But like I would bet Dan has a lot of those materials, and it's just about like, okay, open every file from a folder. Okay, cool. Like find that code. Then it's like combine two images. Okay, well, it's like, how do you do that? So it is really about breaking the thing down into like individual functional pieces and then like slowly operate it, like working through each of those steps.
Okay, cool. Thank you. I will start digging. I know that it requires a lot of practice since I am not a coder. It's kind of a challenge, but I'll do it. Yeah.
Yeah, cool. Fahad.
Yeah, I actually have a question about data sets. So usually I web scrape, and you know, I get a lot of problems like the one I mentioned to you before. But is there like a method or a way, like a source of data sets like you usually look for, or some way to collect the data, like a data set which is basically not that clean, but something you can deal with?
I mean, it just depends on what your data source is. So like, what are you trying to find? A place that I find a lot of good data sets on is Kaggle. Kaggle has a bunch of really great data sets. They usually run competitions where there will be like, you know, who can do the best image detection of satellite imagery, and someone will post like 1 million satellite images taken from Google Maps, and it's all about like object detection, like find a house or whatever. So it just really depends on like exactly what your material is you're looking for. Like, you know, there are shoe data sets, there are, you know, animal data sets, but it's like if you're looking for something specific, it might not exist. So oftentimes I just resort to Google. Like it's just like image data set of, you know, modern paintings. I don't know, like that's like one that probably doesn't exist, or like you have to scrape or find something yourself. But yeah, usually I think Kaggle is a good place to start. I believe Google also has a data sets like search engine. I haven't looked at this in a while, but I think it exists. Yeah, so like, you know, the challenge is like a lot of these are either like very commonly used by everyone, or they are really poorly put together, and you have to like still do some cleanup no matter what. So yeah, data sets is a huge challenge. It's partly why I like these sort of tools, because at least it's like, you know, I built up enough stuff over a couple of years that like, even if I have a web scrape and I've just got a bunch of crappy images, I can start to filter out these things using these tools. So I actually, this 4-channel thing is really helpful. I'm going to write a sort. I'm going to write a sort tool that allows you to sort those images out, because I think it'll be really helpful.
Great, great. So just one more question. When it comes to using a fine-tuned model, I believe that you have to have the same size as the fine-tuned models. For example, if it's 512 by 512, you have to get the same images, the same size. Is that correct?
Usually that's correct, yeah. I mean, sometimes there's ways around that, but for the most part, I would say that is pretty much always, 90% of the time that's true, yeah. So especially for style, again, you need to have the same source image as your underlying image, yeah.
So is there a difference between the fine-tuned, the pre-trained models, or you just use anything since they already learned on layers and stuff?
Yeah, I've talked about this in a couple of videos, and I'll see if I can find some more links to it, like a bigger explanation. But generally, like I find, especially with StyleGAN, transfer learning just works. It doesn't really matter what you train it off of. The only difference is that, so there are two like common pre-trained models that I use from all of my fine tuning. There's FFHQ, which is obviously the face model, and then there's Peter Bailey's WikiArt model. And the reason I tend to use the WikiArt model more often is that the underlying structures are a bit more diverse. So faces, you know, every face looks the exact same. So the underlying structures, which is really what most of the time you're trying to change the most of, are always too similar. But with WikiArt, you get a pretty wide range of underlying structures. So if you have a model, like let's say you've got a model that isn't faces or isn't something where like the underlying structure is always the exact same, I would generally fine tune off of the WikiArt model. Whereas if you have a model that is like other faces, or is something where like the basic structure of the image is always the same, then the FFHQ model is sometimes a good choice.
Great, thank you very much.
Yeah, of course. Yeah. All right, I'm gonna run because we are at 4 hours, and I feel like I need to stand up and stretch a little bit. But if you have other questions, please feel free to drop them in the Slack channel, either in the Datasets channel or in the OpenCV workshop channel. I'm happy to talk through more of this with anyone if you have questions or other thoughts. Cool.
Thanks, Derek.
Yeah, of course. Thank you all so much, and I hope you got something out of this class, and hope to see you again soon. Bye, everybody.